Tradoon. Tradoon.
Girder. Girder.
Ontogeny.
Tradoon.
Blue is cheap.
Tradoon.
Girder.
lend you my graveyard smash.
Doing the Monster Mash with you on this beautiful Valentine's Day.
Marty, why did you play that song today? There must be thousands of love songs.
Well, it's kind of a love song. All the monsters enjoying each other's company, dancing, holding their evil in check.
You played the wrong record, didn't you?
Why are you doing this to me?
Baby, don't hurt me, don't hurt me no more. What is love? What is love? I don't know why you're not there. I give you my love, but you don't care. So what is right and what is wrong? Give me a sign. What is love? Baby, don't hurt me. Don't hurt me no more. What is love? Baby, don't hurt me. Don't hurt me no more. It's up to you. I know very well, just me and you. I can't go. What is love? Baby, don't hurt me. Don't hurt me no more. What is love? Baby, don't hurt me. Don't hurt me no more. This is our life, we're together, I need it forever. Is it love? What is love? Baby, don't hurt me, don't hurt me no more. What is love? Baby, don't hurt me, don't hurt me no more. What is love?
I present to you the top 10 weirdest looking dinosaurs. I want to state the obvious and tell you that I'm going to be butchering the names of these dinosaurs.
Butchering the names of these dinosaurs.
In at number 8, we have the Tradoon. Tradoon.
In 1856, the fossilized teeth of a small dinosaur were discovered in Montana. The species was aptly named Troodon, which means wounding teeth.
Tradoon.
When evolution passed out the stealth gene, Troodons lucked out.
Tradoon.
This drawer contains almost all of the North American identified specimens of Troodon.
Troodon was every inch the predator, with razor-sharp serrated teeth and large, hook-like claws. Troodon probably fed on our ancestors, the early mammals. Troodon may have posed a greater threat to mammals than any other predator on Earth. The Troodon was suddenly cut down in its prime.
Tradoon.
Well, hello, everybody, and welcome to Paleontologizing. It's good to have all of you here today on this special VALENDINOS Day. Glad you could join me. We're gonna have a fun stream, so I hope you're ready for it. If anybody's here for the very first time, allow me to introduce myself real quick. My name is Danny Anduza. I'm a dinosaur paleontologist, and I'm here on Twitch trying to do some good old-fashioned science outreach. Talking about fossils, talking about natural history, talking about, well, a lot of dinosaurs, because dinosaurs, what I actually study, what I publish on in the scientific literature, what I dig up during the summers. That's why I'm a dinosaur paleontologist. Most paleontologists don't work on dinosaurs. Dinosaurs are just the tip of the iceberg, but they are what I work on. And today we're going to be talking about dinosaurs. We're going to be talking about dinosaur hearts in honor of Valentine's Day, because we do actually have a few things to say about dinosaur hearts. There's some tantalizing evidence we get from the fossil record about what dinosaur cardiovascular musculature would have been like. And then we'll be talking about dinosaur courtship and what information we can glean about how dinosaurs courted one another based on fossil evidence. It's gonna be a lot of fun. I don't know if we'll have time to get to Thursday Birds Day later. We might have a 3-week Thursday Birds Day backup. We'll have to see. But anyway, it's good to have you here, everybody. And if you've got any questions at all, not just about dinosaurs, not just about today's topic necessarily, but about paleontology in general, about the history of life on Earth, about extinction and evolution and the fossil record, and the very philosophy of science itself, do not hesitate with those questions. That's why I'm here in the first place. This is my full-time job, believe it or not. This is how I make my living, is doing science outreach here on Twitch, and I do my very best to give you an inside peek into how paleontology works. Hence the name of this channel, Paleontologizing, is, well, it's meant to take paleontology and turn it into a verb. If that makes sense. And Darius Majewski, thank you for the 2 months of support. I appreciate that very much. Good to have you here. And that guy Nate says, my first time watching, your channel was in my recommended list, so happy to find this part of Twitch. Welcome. I promise you, I don't normally dress like this. And my office doesn't normally look like this. It's a special stream today in honor of Valentine's. But it's good to have you here, everybody. Yeah. Happy Valentinos. Let's see who's here in the chat. I saw up at the top, who was it? Kodali and Matt M33. Claire Burr and Victorious. Diet of Beatus, the Lenina. How you doing, Lenina? Chaotic Time Traveler, Salamander, Chris T.S., Helvetica Scenario, Golganek. Claire Burr, of course. Did I say you yet, Claire?
But when you find something like this, it may be something that's never been seen.
Lala Keika, thank you for the follow. Welcome, welcome. And holy cow, Mark Melvin, 10 gift subs. I really appreciate that generosity. Thank you for that. Check out this beautiful Tinamou bird here. Super excited for that generosity displayed by Mark Melvin. Oh, shoot.
Mark Melbourne is overloading the system with 10 gift subs.
Thank you, Mark Melvin. There's 10 lucky chatters who won't have to watch any ads for the next 30 days. Thank you for that, Mark Melvin. I appreciate it. And thank you, Hogan, for the 100 bits. Beautiful. We got a hype train going here. Swiftly approaching a level 3. Let's see how far that can go. Thank you for the support. Again, this is my full-time job, so you're literally putting food on my table. I appreciate that, Mark Melvin and Hogan. Good stuff. We've got Lilith Obo and Ms. Art Rules. Scrolling. Alexander Morrison and Rushwing. Bush Doctor. Marcy Walks Dogs, Not the Brain. Victorious Zote. Milicia Total. Bienvenidos. De Growly Bear. Don Juan de Paleo. Good to have you here, De Growly Bear. Enjoy this while it lasts. I'm going to have to take it off because it's going to get too warm. I can maybe delay that somewhat. Let me drink some ice water. Anywho. Arle, how are you doing? Happy Tribune to you too. Arle, hope you're having a good day and a good week. Who else have we got? Charcone, hello. Peppercat 8, looking fancy, thank you.
I can see that my 50,000 a year has been well spent.
Yeah, that tier 3 sub. Thank you, Victorious. I really appreciate it. Thank you for your ongoing support, Victorious. Good stuff. That must be warm if you drink that much ice. I tend to run pretty hot anyway, so yeah. Oh boy. But yeah, some fossilized droppings on a walk recently. You think you found some? Were they just on the ground, or did you find them in like an outcrop of rock? Because I don't know. Coprolites are not necessarily rare, but they're not often the sort of thing that you find while out on a walk. Oh, in a riverbed. Interesting. Have they got like a little coily shape to them? Because that's one of the best ways to identify them, especially if they're from like a croc or something. Anywho, yeah. My 5-year-old nephew and I were looking for ammonites. Oh, very cool. That guy Nate, very, very cool. Wow. Everybody, we are, like I said, going to be talking about. Oh, thank you, Ms. Art Rules.
Happy Dinolove Day, my favorite science comtiao Palia salute.
Thank you, Ms. Art Rules. I appreciate the 200 bits. I appreciate your support. Your kind words. Thank you, Ms. Art Rules. Good stuff. Today we're going to be talking about some dinosaur topics that we can relate vaguely to Valentine's Day. So, yeah, but before we do that, let me turn on this fan over here. We'll see if we can prolong my wearing of this if I've got some air blowing on me. See if that helps at all. And thank you, Lenina, for gifting Eddie Scarin. I appreciate that, Lenina. Thank you very much. Good stuff. Yeah. Excellent. Yeah. Well, and Suave Oreo, thank you for the 4 months of support. I appreciate that. Thank you. Keeping me here online. Foulbox says, is this real? No, sorry. This is just a dream. But when I snap my fingers, you will wake up. You ready? Did it work? Don't snap. Oh, sorry. Too late. Hello, Foulbox. Welcome to Paleontologizing. You've joined us on a special Valentine's Day episode. We're going to be talking about things I can loosely tie to Valentine's Day with regard to dinosaurs. We're going to be talking about dinosaur cardiovascular anatomy, dinosaur hearts, and how we can learn what dinosaur hearts may have been like from the fossil record. Same for dinosaur courtship behavior, dinosaur mating dances, dinosaur display behavior. What can we learn about dinosaur courtship and possibly dinosaur reproductive behavior based on the fossil record? We'll be talking about that too. So yeah. And very nice, Golganek. Yeah, we'll see if we have time for Thursday Birds Day today too. No guarantees. We'll see how it goes. Live broadcast, just about anything can happen. But Lottie Finchy, hello to you. And again, if anybody's just waltzed in, welcome. My name is Danny Anduza. I'm a dinosaur paleontologist. I study dinosaurs. I publish on dinosaurs in the scientific literature, in scientific journals. And nowadays I make my living talking about dinosaurs here on Twitch. And then during the field season, I'm out in the Badlands digging up dinosaurs live on stream. Like you see
I've been studying paleontology on Twitch for more than 4 years now. I started in May of 2020, and I've been doing these fieldwork streams for a few years as well. But it takes a lot of equipment to be able to do that, you know. The satellite dish, solar panels, solar battery, and...
we got a smaller satellite dish for this year. Should be pretty useful.
A lot of equipment to move around. But I'm lucky it's mostly portable. Yeah. And so far, the weather's been lovely. We've actually got these beautiful clouds going on right now.
Yeah.
We are working in western Wyoming.
It's also very cloudy where I am at
near
present.
The town of Green River, Wyoming. While it's very dry out here, that also means it's not super rainy, which is nice. It's not...
Yeah, I kind of wish it was like that right now, where I'm at in the beautiful sunny San Francisco Bay Area. Although today it's not particularly sunny. It's actually, it's actually very overcast and rainy. You can barely see San Francisco there.
This is the Rosetta Stone of meat-eating dinosaurs.
And there is no such a thing as a Rosetta Stone in science.
Mommy does. Thank you for the 34 months of support. Now at tier 2. Thank you for that, Mommy does. I appreciate you. Thanks for keeping me here online. Yeah. Berkeley, Emeryville, San Francisco, Marin. Very cloudy and rainy today. Yeah. Yeah. I'm in the UK, so our weather's just gray all day. I hear you there, Foulbox. Yeah, well, I hope you're doing well regardless. It's good to have you here. Ms. Art Rule says, do you think there would have been any extinct dinosaurs that would mate for life? There's several extinct birds that I'm sure probably would have. Although, I know people don't like to hear it, but many of the birds that mate for life, they're not actually as strict about that as you've been led to believe. There's often a lot of kind of sneaking around on the side. Anytime there's like a detailed study of mate fidelity in birds, the conclusion always seems to be like, oh yeah, shoot, there's actually some cheating going on. Yeah. So mating for life is one of those things that is... it's not as cut and dry as you would think. Yeah. But yeah. Yeah. And Kylie BSS says, have you seen the dinosaur tail that was preserved in amber? I think it turned out not to be from a dinosaur, right? Are we thinking of the same thing? It was from Myanmar, from Burma, right? Yeah. And Not the Beast says, bird infidelity is nothing sacred? I mean, unfortunately, yeah, sometimes nature is a little bit more complex and messy than we would like it to be, you know? So, yeah. Who is the artist on the cover of What is Love? Helvetica Scenario? Let me see if I can find that for you. Was it this one? Yeah. The Guitaraculas. Let me find you a link. Copy link address. There you go. That should do it. There you go. Enjoy. Maxwell Paxton says, I dig your groovy smoking jacket. Woohoo. Thank you. I appreciate it. It's awful warm. Let's see how long I can continue wearing it. But, yeah. Happy Valentinos. Good to have you. Oh no, Hogan. Yeah, that probably means they're gonna eat you, Hogan. But, I don't know. Are they carnivorous? Proceed with caution. And Jay Court says, somehow my 2-year-old nephew got into dinosaurs. He has a bucket full of dinosaur toys. Very cool.
Trudune.
Whatever you can do to feed that interest will probably be really good for him. Yeah. Here's a press release from CNN that's associated with a research paper about this topic. Yeah. Let's see here. 2008 study found that sustained intense interest, particularly in conceptual domains like dinosaurs, can help children develop increased knowledge and persistence, a better attention span, and deeper information processing skills. In short, they make better learners and smarter kids. There's decades of research to back that up. 3 separate studies have found that older children with intense interest tend to be of above average intelligence. I can probably read out loud better than I can too. A dinosaur obsession then can be a kid's way of taking in new subjects in a way that feels familiar to them. Through the business of having fun, asking questions, finding answers, and gaining expertise is the learning process in general, Chen says. Chen must be a researcher involved in this. Exploring a topic and mastering it is beneficial because that's how we form careers as adults. A kid's primary occupation is play, so they're going about their job of playing through the lens of the thing that they're interested in learning about. So anyway, good stuff. Here's a link to that, and presumably there are links in here to some of the studies here. Yeah, where was it? 2008 study. There we go. The development of conceptual interests in young children. Anyway, cool stuff. I don't know. I think that's one of the ways in which dinosaur paleontologists like myself serve the public at large. It's like here. Here we go. Like Louis Jacobs, paleontologist, says in this clip.
Hi, my name is Louis Jacobs, and I'm one of 2,300 vertebrate paleontologists from 54 countries that belong to the Society of Vertebrate Paleontology. Because we study fossils, especially dinosaurs, we capture the imagination of children, and that makes vertebrate paleontology a gateway for all science. Here are some of the faces of the Society of Vertebrate Paleontology today.
I'm a member of SVP, by the way. Proud member of the Society of Vertebrate Paleontology. He makes a good point here. Dinosaurs are a gateway into the sciences. There are so many different people working in knowledge fields around the world today. Scientists, philosophers, engineers, physicians, and researchers of all stripes. So many people who are helping to improve our world, and they first fell in love with the idea of learning because they loved dinosaurs when they were a kid. When these people were children, many of them, their first introduction to like a conceptual domain was dinosaurs. And so sometimes you hear this phrase like, oh, you know, dinosaur science, paleontology, dinosaur paleontologists, they've got a cool job, I guess, but it's not like they're going to cure cancer or anything. Is it really that important? No, it really, really is. Because if anybody ever does cure cancer, there's a good chance that that person who cures cancer would have first gotten interested in learning because of dinosaurs, because of the discoveries that dinosaur paleontologists make. Like, I really do believe that we have an extraordinarily important role in society. We're making the discoveries that inspire people. And I'm not trying to like toot my own horn here. I'm just, you know, trying to advocate for the importance of the kind of work that my colleagues and I do. Does that make sense? Yeah. Yeah. And DeRozan says, me, cancer research scientist here. Ding, 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 ding. Loved dinos as a kid and still do. There you go. DeRozan, that's wonderful. Yeah. That's one of my goals for this year, is I want to actually do a peer-reviewed study on this. I want to team up with some researchers in other fields who do cognitive science, who do surveys of, you know, sort of like meta-science stuff. It would be nice, really, really nice. It would be wonderful. The goal is to have a representative survey of people in different fields and ask them how many of you first fell in love with learning because of dinosaurs.
Invaluable.
Moculus, thank you for the 22 months of support. I really appreciate that. Thank you, Moculus. I appreciate you. But yeah. Yeah. Anywho. Yeah. And Notes from Krautland says, I mean, it is true. My wonder book, The World We Live In, well, the pages I remember are about dinosaurs and then space. Notes from Krautland, is that this book over here? From Time Life. I just got this the other day because I know this was remarkably influential for a lot of people. I've heard from many, many people.
No other creature in the world looks like a half-plucked turkey and walks like a pot-bellied bear.
MLF, thank you so much for the 19 months of support. Really appreciate that. Thank you, MLF. Yeah. from 1955. Interesting. This is going to be more recent than that, I presume. World We Live In. By the editorial staff of Life magazine and Lincoln Barnett. Oh, copyright 1952. Well, well, well. That's the first printing. Was 1952. 1962 was the last time it was printed, apparently. This must be the 1962 version I've got right here. But, yeah. A lot of this focuses on Rudolf Zallinger's The Age of Mammals mural series here. But I do think we've got some dinosaurs in here too. Oh, that's lovely. There's a sawfish. Gotta love sawfish. Yeah. I don't know if there's many dinosaurs in here, but I've heard from multiple professional paleontologists who are in like their 60s today that book was incredibly influential. That it was really inspiring to them when they were kiddos. In fact, Michael Novacek talks about that in his kind of field autobiography called Time Traveler. Let me grab that off the shelf and we'll read that excerpt. Here we go. One of my very favorite books, actually. Michael Novacek's Time Traveler. But right at the beginning... Let's see... He talks about reading this book in class when he wasn't supposed to. I wonder if it's in the index, actually. The world we live in is a proper noun, so certainly fit for an index. I don't see it. Find this for you. This is, again, one of my favorite books because it's written in such a charming way. Novacek just has this kind of effortless style. There we go. Yeah. So, he writes at the end of this chapter, it's the first chapter of the book, kind of like recalling his childhood, and, you know, Michael Novacek, right here, he would go on to become a pretty well-known vertebrate paleontologist.
To go out in the field and work with a professor from UCLA who was a paleontologist. I guess what I said at the end of that field season is, oh, you can do this for a living? This is amazing. When you've been looking in the field so many years, and even when you're successful, you might look for many days or many weeks and find one or two fossils and feel like you've accomplished a lot. Sometimes you'll have an expedition where you don't find anything and you've spent a lot of time, as we did in Yemen many years ago.
That's a really funny chapter in this book, actually.
We haven't found anything there.
Yeah.
And after much 6 weeks of work. So after all that work and all those years, to really strike it big, you're a little skeptical that you've actually accomplished this.
Yeah. So yeah, he writes at the beginning of his kind of autobiography here, the La Brea tar pits, because Novacek grew up in Los Angeles. The La Brea tar pits and the fossils embedded in them were, to me, a miraculous gift to Los Angeles. In Catholic school, a nun who had visited Lourdes regaled us with tales of the astounding cures that came to pilgrims who partook of the holy waters there. But Lourdes did not seem at all interesting to me. Even at the age of 10, I developed a skepticism for the mystical and the unexplainable. La Brea was both fantastic and real. Religious lore could not compete with its vivid evidence. My predilection for empiricism was not always rewarded. The same nun who waxed poetic about Lord had divided our 4th grade class into 3 sections according to a scale of perceived intelligence and acceptability. The first 2 rows were the dummies. The east 2 rows, the smarties. And the middle purgatorial row, where I held a place of dubious honor, the spacemen. I tried to transport myself out of that miserable place as often as possible, usually by concealing my favorite science book behind a catechism for a surreptitious read. One day I savored the diorama painting of Ice Age mammals and the large, not so easily concealed Time Life book, The World We Live In. This book right here that we've been talking about. The nun swooped down on me and wrapped my hands. "There you are, once again, reading about monsters," she shouted as she threw the book to the floor and gave it a permanent stamp with her dainty little shoe. I was held after school, but I got the book back. Later that afternoon, I sat on the porch at home reading the forbidden World We Live In and sipping lemonade. I daydreamed about a Los Angeles lost in time with its ground sloths, mammoths, and saber-toothed cats. I extended the dreamscape beyond my hometown to the Montana Badlands, where Tyrannosaurus took rest, and to the empty red deserts of Central Asia, where the first dinosaur nests and the first complete skeletons of primitive shrew-like mammals, presumably the marauders of dinosaur nests, I don't know about that, had been discovered. I dreamed of all the continents, canyons, and quarries still waiting to be plundered for fossils. It was good to be a spaceman. Love this book. And that's one of many mentions that I've heard over the years of this book. So I finally had to get myself a copy the other day, and I'm glad to have it. It's really nice to have a physical copy of a book that you know has been really influential to a lot of people. So, good stuff. Yeah. Anywho, welcome, Science Streams. Hey, happy Valentinos. It's good to have you here. Welcome. Yeah. And Carlin says, just go back a few pages for the mammals. Do we have dinosaurs there? Let's see. What? Sorry, I hit the soundboard. All right. We've got our mammals. Yeah, nope. Table of contents, and then the Age of Mammals. Maybe there are books that are, maybe there are editions of this where it's, like, there's multiple volumes in one book or something? I don't know. But this jumps straight into the mammals here. Yeah. You just overpaged it, said Notes from Krautland. The mammals take over the Earth. The Age of Mammals. Table of Contents. So no, I didn't overpage it. It's not in here. Yeah. So it would be, I guess, in Volume 1, The Pageant of Life. So, like I said, there's probably... You can probably get multi-volume editions of this. This is just Volume 3. Or Volume 2, rather, The Development of Life. Yeah. Anywho. Yeah, mine was a single volume. So there you go, Krautland. Yeah, that makes sense. Like I said. Anywho. Good stuff. Good stuff. I gotta readjust this fan because it's not quite cool enough. This thing. Yeah. And from Kylie BSS, the dinosaur tail that I found. They preserved an amaryllis covered in feathers. I don't know if that actually turned out to be a dinosaur. I think it turned out to be a bird. But, here. Yeah, from 2016. I think this was... I think it turned out to be a bird. Yeah, here we go.
A feathered dinosaur tail was found preserved in amber. The
This
modern
is
view on
back
dinosaurs
in
is that
2016.
they did not truly become extinct. That's because birds are dinosaurs. We've
this is
seen
true,
fossil
yeah.
evidence of feathers on dinosaurs before, but this time, researchers have found a feathered dinosaur tail in amber. The study was just published in the journal Current Biology. A piece of amber was found in Myanmar. Researchers examined the sample with scanners to find out more. They believe the sample contains at least 8 full vertebrae and part of a 9th. So which dinosaur is this tail from? Well, the sample is thought to be from the mid-Cretaceous period. By examining its
So it
vertebral
wouldn't be
profile
from a
and
known
estimated
dinosaur.
length, the dinosaur is believed to be a coelurosaur. Examples of coelurosaurs include
So I'm pretty sure it turned out that this was from a bird, which, yes, indeed, birds are dinosaurs, as people are shouting in the chat. Yeah, but usually when people say dinosaur, they often mean non-avian dinosaur. So I was trying to kind of, go with that. But yeah. Silver earthquakes in the Berry, did you feel them? No, not at all, Otterduit. Not today, at least. There was one a little while ago, like a couple weeks ago. But, yeah. Maybe it was from a non-avian dinosaur. I'm pretty sure, though. Hang on. Let me see if I can find this, because I'm pretty sure one of my colleagues at Montana State was publishing on this, published a rebuttal paper. Let's see. Yeah, here we go. I hope I'm not misremembering this. But avian tail ontogeny, pica-style function, and interpretation of juvenile Mesozoic specimens. Dana Rashid. You might recognize that name. She was, I think still is, lead on the Dino Chicken project. Kevin Soria. He's one of my old roommates when I lived in Montana. Also Luis Chiappe, bird expert at the Los Angeles County Museum. Nathan Carroll, who is one of Chiappe's students. Nate Carroll is now curator of the Carter County Museum in Ekalaka, Montana. I've done a lot of work with Nate in the past. Alita Bayul, I've worked with her also in the Hell Creek back in 2011. Jingmei O'Connor is now at the Field Museum in Chicago. She's been gifted this lovely Archaeopteryx specimen to work on, and she's going to do some really cool stuff with that. Very excited for it. And Jack Horner, my old boss. So lots of people I know on this paper. Let's see. These findings call for reinterpretations of Zongornis howe, Cretaceous bird hypothesized to be an intermediate and long to short-tailed bird transition, and of the recently discovered coelurosaur tail embedded in amber. Yeah. Here, we'll take a look at this paper. There's a link, but I'm pretty sure in here I want to say that Dana was talking about how she doesn't think it's actually a bird or a non-avian dinosaur tail. She thinks it's a bird tail in the amber. The ontogenetic morphology changes in caudal vertebrae indicate the recently discovered coelurosaur tail in amber may require reevaluation. There we go. The specimen consists of a preserved tail with 10 vertebrae and attached feathers. Its highly elongated vertebrae and frond-like configuration of retrices suggest a long tail, and thus it likely did not belong to the Pygostylia group. However, incompleteness of the material and inferences that the specimen is a juvenile obscure its phylogenetic placement. The specimen was interpreted as non-avian, so not a bird, another kind of dinosaur, based on feather morphology, its age, 99 million years ago, and the absence of vertebral processes, and the concave ventral furrow in the vertebrae not seen in the long-tailed birds Archaeopteryx gihlornis. Concerns regarding the interpretation of the feather morphology have already been raised. In terms of age, fossil beds preserving Cretaceous avian specimens younger than 120 million years are relatively scarce. There is no reason to exclude the possibility that long-tailed birds existed at that time. In fact, the 75 million-year-old Rhehonavis ostromi from Madagascar, with its long tail preserving 13 vertebrae, has at times been considered a non-avian dinosaur and other times a bird. The lack of vertebral processes in the amber-embedded specimen may be due to its juvenile state, as seen in the unmineralized processes in juvenile extant bird tails analyzed in this study. So sometimes the tails of, well, some bones in birds don't really like ossify. They don't really turn to full-fledged bone until later in ontogeny. These aspects question the characterization of this specimen as non-avian. Alternatively, it could have been a long-tailed bird, as has been independently suggested. So it could be that the dinosaur tail preserved in amber, it would still be a dinosaur, it would just be an avian dinosaur, a bird. That's what Dana thinks, and that's what a number of other researchers think too. But that's not as flashy a headline, so it's not going to be as widely reported, you know? So yeah. Mizar Rule says, can they do a histosample on it? This is going to be too small, and if it's a bird, you're not really going to find much in the histo, because birds grow really quickly. Yeah, so not so sensational after all, says Alexander Morrison. It would still be really cool. Oh, Not the Beast says, that's why bird law is so important. True, yeah. Shout out to all the hardworking bird lawyers out there. Yeah. An official Curly TV says, what do you think of the Chickenosaurus project? Was it just fake or not? It's definitely not fake, no. I was obliquely involved with the Dino Chicken project. So here we go. Here is Dana Rashid, lead researcher on the Dino Chicken project, talking about it back in, what was this, 2018? Something like that?
Has a human ever ridden a dinosaur? My answer, as an evolutionary biologist, may surprise you. Well, an ostrich is a bird, and we now recognize that birds are dinosaurs.
Yep.
So by riding ostriches, yes, indeedy, humans have ridden dinosaurs. Why anyone would want to ride an ostrich is a completely separate question.
It's because it's cool.
But what's wrong with the panel on the left? Time. Time is what's wrong. This sort of non-avian dinosaur went extinct tens of millions of years before humans ever came on the scene. Time and its relation to evolution is one of the things I'll be talking to you about today.
So let's jump to the Dino Chicken project here.
It takes a really long time, not just for all of these changes to occur, but for them to be selected for and to spread throughout a population. What I study is the long, deep evolution of birds from Mesozoic dinosaurs. I've been working with Jack Horner on this project, the Dino Chicken Project, and it was indeed inspired by the Jurassic Park movies.
Jack bring Dana on
is
here
famous
at
for saying,
some point.
why don't we turn a chicken into a dinosaur? Why not? He surmised that we could learn a heck of a lot about dinosaur-to-bird evolution, and as usual, he was right. But there's a lot to study here, because we're looking at about 150 million years of evolutionary change between what is generally regarded as the first bird, Archaeopteryx, my favorite dinosaur, and say a modern chicken. Because there's a lot to study, we had to narrow it down. we decided to start with bird tail evolution.
And this turned out to be the most difficult part of the whole Dino Chicken project. Because as it turns out, there's a lot of somatic stuff that's going on with this. The resorption of the tail vertebrae in vitro, it's actually tied to like the development of the immune system and stuff like that. So if you stop the tail from resorbing, you're also stopping the spinal cord from developing and the immune system from actually like working properly. But anyway, you might be wondering, like, why in the world would you want to create a weird bird that looks superficially like a dinosaur? Why would you want to do that? Jack Horner has an answer for that. This was his idea in the first place. And he wants to do it as...
Because evolution works, we actually have some evolutionary tools.
Yeah.
We'll call them biological modification tools. We have selection. And we know selection works, right? I mean, we started out with a wolf-like creature, and we end up with a Maltese. I mean, that's definitely genetic modification.
Yeah.
But as you can see, the pigeon or a chicken or anything else, so like a bird, has kind of a weird-looking hand because
they've got highly modified
the hand is
very specialized.
But the cool thing is that if you look in the embryo, as the embryo is developing, the hand actually looks pretty much like the Archaeopteryx hand. It has the 3 fingers, the 3 digits. But a gene turns on that actually fuses those together.
Yep.
And so what we're looking for is that gene. We want to stop that gene from turning on, fusing those hands together, so we can get a chicken that hatches out with a 3-fingered hand, like the Archaeopteryx. And the same goes for the tails. Birds have basically rudimentary tails. And so we know that in embryo, as the animal is developing, it actually has a relatively long tail. But a gene turns on and resorbs the tail, gets rid of it. So that's the other gene we're looking for. We want to stop that tail from resorbing. So what we're trying to do, really, is take our chicken.
Is that rule says so it would be a hybrid bird dinosaur, basically? No, not a hybrid. It's 100% chicken. A hybrid is a mixture of 2 different animals. You know? This would not be that. This would just be a chicken that you tweak a little bit to make it superficially resemble a non-bird dinosaur.
Modify it and make a chickenosaurus.
Yeah. So genetically it is 100% chicken. You're just changing how some of the genes are expressing in order to create this.
It's a cooler looking chicken. I mean, but it's just the very basics.
Yeah.
So that really is what we're doing. And people always say, well, you know, why do that? Why make this thing? What good is it? Well, that's a good question. You know, actually, I think it's a great way to teach kids about evolutionary biology and developmental biology and all sorts of things. And quite frankly, I think if Colonel Sanders was to be careful how he worded it, he could actually
Colonel Sanders is dead.
Advertise an extra piece. Anyway, when our dino chicken hatches,
anyway, his idea, Jack's idea with this, I thought he said it in this clip, but I guess he doesn't. He said he wanted to be able to walk on stage with a dino chicken under his arm and then just set it down, let it walk around, and be able to say to an auditorium full of kids, what is this? Is it a bird? Is it a dinosaur? Is it both? It's a way to get people's attention. It's a way to get them to think about evolution. It's a way to help illustrate some of these concepts in a way that isn't arcane or academic or conceptual. It's right there in front of you. It's right in front of your nose. You're confronted with this, and you got to think about it and talk about it. I think that's really cool. In the same way that, like, in the 1960s, the space race, the Apollo project, it got everyday Americans to think about science as something immediately relevant, something inspiring, something that they're confronted with in their daily experience. You could do that with rocketry. Maybe you can do that with dinosaurs and with birds, too. That's kind of Jack's idea there, you know? But, in pursuing this project, there are, kind of like with the space program, spin-off benefits that nobody really could have anticipated, too. Here.
If we can understand how changes in DNA cause physical changes, we can better understand how traits evolve, and we can better interpret the fossil record.
Yep.
Since the Dino Chicken Project is an out-of-the-box type endeavor, we've made some out-of-the-box discoveries. One surprising finding is a correlation with ankylosing spondylitis, a human disease where your vertebrae fuse together and the discs between your vertebrae can erode. It's a rather horrible, debilitating disease, and it looks a lot like the fusion of bones at the end of the chicken tail. Since there's no good animal model for ankylosing spondylitis, we're proposing to study it in the chicken.
Yeah.
Who knew?
So this awful disease, and I was talking with Dana about this. I think it was her father-in-law has or had, not sure if he's still around, ankylosing spondylitis. And it's horrible. When your vertebrae fuse together, it's awful. And right now, we don't have a great way to study this. It's not like you can study it in mice, or you can study it in, I don't know, possums, or some other lab organism like that. Study it in African clawed frogs or something. The hope is that by understanding how the bones start to fuse up in the tail in chickens, through the pursuit of the Dino Chicken Project, if we can figure that out, if we can actually understand on a deep level what causes the fusion of those tail bones, we can understand what might cause the fusion in ankylosing spondylitis, because right now, there's not a good handle on that. So the Dino Chicken Project, it's allowed to continue if it's well-funded, if they make some breakthroughs here, there could be a potential spin-off cure for diseases like this. This is how science works, you know? You never know what you're going to discover. This is why basic research is so incredibly important, you know? So yeah. Irady Ken Wife says, I have spondylitis in my lower back. Folks, it is not fun. Yes. This is a nasty, nasty disease. And I don't know if there's been a lot of progress in treating it over the past few decades. Largely because that kind of basic research in like what actually causes vertebral fusion, I don't think a lot of that basic work has been done. Nobody's really been studying that, as far as I know. And a big part of that is like we don't have a good animal model for this. So yeah. Kind of going on that same idea. Here, yesterday, when we were talking about different animals' skulls, remember I showed this off? The skull of a Gila monster? Like, how cool looking is that? What an incredibly neat looking skull. Well, researchers studying Gila monsters happened to make a really interesting discovery that has had like multi-billion dollar
By now,
consequences. Take a look.
By now, it's likely you've heard of Ozempic.
Ozempic's being used by the rich and famous.
The diabetes medication which has been making headlines for weight loss. But perhaps a lesser-known fact is that Ozempic has ties to Canada. And, well, if you can believe it, a lizard.
Yep.
That lizard. A Gila monster, which is a venomous reptile native to the southern U.S.
I did basic science.
And Mexico,
I really
too.
had no idea where this would lead.
In the 1980s, Canadian researcher Dr. Daniel Drucker discovered a hormone in the human gut.
And it was a very powerful stimulator of insulin secretion. And very importantly, it only stimulated insulin secretion when the glucose was elevated.
He and many other scientists were trying to figure out how to turn it into a diabetes drug. The problem was that manufactured samples dissolve too quickly.
So here's the thing. Scientists studying the venom of Gila monsters, and this is a venomous lizard, they noticed like a novel chemical compound in that. And they're like, oh, I wonder if this could be turned into like a diabetes drug or something. And then there's this weird spin-off here.
But Drucker had heard about a lizard down south whose venom had a similar hormone with more staying power.
In the 1990s, there was no gene banks. You couldn't look stuff up online. You actually had to clone stuff. And in order to do that, we had to get lizard DNA.
The Royal Ontario Museum gave that job to...
Yeah, the ROM! Several of my my friends and colleagues graduated with their PhDs from the ROM, from the Royal Ontario Museum. They have an excellent paleontology collection here. Dave Evans is kind of like a... he's a real mover and shaker in the dinosaur paleontology world. And several of my friends and colleagues, Jade Simon and Kerry Woodruff and a number of others, they've graduated from the ROM under Dave Evans. Yeah.
To Bob Murphy.
We arranged for the purchase of the lizard and its shipment as airline cargo to Toronto. Pearson, I picked it up.
It paid off. Decades later, the medical community is taking the discovery to new heights. Not only is this technology being used to make Ozempic, treatments for Alzheimer's, addiction, and heart disease are also in the works.
The reality is that this is a very strong network of scientists communicating and working together.
Proving that breakthroughs can happen just about anywhere.
It's having
Pretty
a
cool.
huge clinical impact globally, which is just great to see as a physician.
Catherine Ward, Global News, Toronto.
So again, to go back to the beginning of this, I want to emphasize this point. He says, we were just doing basic research. When I say basic research, what I mean is these people got a grant or some kind of funding to be able to study something that's just for pure curiosity's sake. It's like we want to understand how this particular thing works in nature. We don't have an end goal in mind. It's just pure scientific curiosity. We just want to know how it works. Because we think it's cool, because we're curious about it, because we're scientists.
Southern U.S.
I did basic science. I really had no idea where this would lead.
And there's so many cases of this where someone just has an interesting research question and they come up with a way to ask it, some experiments to run, they get funding, they carry it out, and then, holy cow, something incredible comes out of it. The importance of basic scientific research is something that I will talk about all day, every day, if you let me. You know? It's... And Claire Bird, now, you don't have to harvest it from... Ozempic doesn't come directly from Gila monsters. There was like a novel chemical compound that they found in these lizards, and then they were able to synthesize it in a laboratory after that, as I understand it. So it's not like these animals are being harvested from the wild. So don't worry about that. So here. This is an article from 2013, but it is never been more relevant than it is right now, I think. This is from Slate magazine. Why I studied duck genitalia. Fox News and other conservative sites missed the point of basic science. Basic research. And basic research is the kind of research that's just done for curiosity's sake. Because we're scientists and we're curious about things and we want to understand how the world works. You know, it's not like you're trying to manufacture the next multi-billion-dollar product, or you're trying to manufacture a weapon that can effortlessly disintegrate brown children on the other side of the world or whatever. It's got real military application like that. Like, no. We're scientists. We're just trying to do science, you know? Basic science. So in the past few days, this is back in 2013, the internet has been filled with commentary on whether the National Science Foundation should have paid for my study on duck genitalia. And 88.7% of respondents to a Fox News online poll agreed that studying duck genitalia is wasteful government spending. The commentary supporting and decrying the study continues to grow. As the lead investigator in this research, I would like to weigh in on the controversy and offer some insights on the process of research funding by the NSF. So this is really relevant because the NSF is currently in the process of being defunded by the Trump administration by Elon Musk. So that's why we're talking about this right now, is this is immediately relevant to our present time right now. You know? So my research on bird genitalia was originally funded in 2005 during the Bush administration. Thus, federal support for this research cannot be connected exclusively to the sequestration or the Obama presidency, as many of the conservative websites have claimed. Since Senator William Proxmire's Golden Fleece Awards in the 1970s and 1980s, this is a thing where, yeah. Sometimes conservative politicians will go, they'll find instances of public funding for science. And they'll go, oh, that sounds ridiculous. We should cut that. That's money that's wasted. That money would be much better spent on tax cuts for the ultra wealthy than by, you know, funding scientific research that will benefit the world and society at large. That's what the Golden Fleece Awards were about, basically. So since the Golden Fleece Awards, basic science projects are periodically singled out by people with political agendas to highlight how government wastes taxpayer money on seemingly foolish research. These arguments misrepresent the distinction between the roles of basic and applied science. Basic science is not aimed at solving an immediate practical problem. Basic science is an integral part of scientific progress, but individual projects may sound meaningless when taken out of context. Basic science often ends up solving problems anyway, but it is just not designed for this purpose. Applied science builds upon basic science, so they're inextricably linked. As an example, GeckSkin is a new adhesive product with myriad applications developed by my colleagues at the University of Massachusetts. Their work is based on several decades of basic research on gecko locomotion. Now, geckos Geckos are remarkable animals because they can climb straight up smooth glass surfaces like this. How in the world can they do that? It almost seems like magic. Seems like a superpower, right? And it's not well understood. So, an example of basic research is just asking, hey, how's this thing work? How are geckos able to do this? You're not trying to build a product that'll make $1 billion. You're not trying to find something that will have immediate military applications or something that will cure cancer. Which is kind of the opposite of military application. Anyway, It's just basic day-to-day scientific research, you know? Skin was a product that was the direct result of that basic research. So sometimes basic research does result in crazy stuff like this, in tremendous benefit to society. But you can never tell when it will or when it won't. Oftentimes you can't have the applied research until the basic research is done. And basic research is one of those things that if you don't have that, you don't have science. If you defund basic research, you're defunding science. And if you're part of if your country's government defunds basic scientific research, your country will fall behind. And other countries will pass you up. And you will be left in the dust of history. You will be outcompeted by other countries. Like will happen to the United States. China will absolutely eat our lunch. They will surpass us in scientific discoveries, in new technologies. It's game over for us if we go through with this defunding of science like the Trump administration is currently trying to do. That is a bullet to the head of American innovation. And it's self-inflicted, you know? It is embarrassing, Lenina. It's absolutely embarrassing. Notes from Carlin says, I think fund schools the right way, and the rest will take care of itself. No, because if you fund schools but you don't have funding available for science in your country, then all of the students, even if they have an excellent education in that country, they'll just move to other countries when they become scientists later on. You get that brain drain, so that absolutely will not work. You need to have a whole... all these different stages of ontogeny for scientists, from basic education when people are really young, up until funding the research of career scientists when they have careers. You need to do that all the way through, or you will fall behind, and countries like China are absolutely doing this. So yeah. And DeRozan makes a really good point here too. Again, vinblastine and vincristine. I've never heard of these before. These are two essential chemo drugs developed from compounds found in the periwinkle flower. Without someone researching pretty flowers, we'd never have found those. There you go. I've never heard of this before. There's probably 1,000 examples of this that I have never heard of. I have no idea about. And these things are incredibly common. So yeah, hello, sweetie pie. How are you doing? Welcome, welcome. Here. Getting back to this. Whether the government should fund basic research in times of economic crisis is a valid question that deserves well-informed discourse, comparing at all governmental expenses. As a scientist, my view is that supporting basic and applied research is essential to keep the United States ahead in the global economy. The government can't afford to not make that investment. In fact, I argue that research spending should be increased dramatically for the United States to continue to lead the world in scientific discovery. Investment in the NSF is just over $20 per year per person. I spend so much more than that on my own research and funding the research of colleagues, like directly. But yeah. Well, it takes upward of $2,000 per person per year to fund the military. Oh boy. Basic research has to be funded by the government rather than private investors because there's no immediate profits to be derived from it. If you just go by the profit motive, if you let the profit motive govern everything in your society, You will not have a society in a few years. You will absolutely devolve into complete and total anarcho-capitalist mayhem. Society will collapse. Because society itself is not profitable. Human flourishing is not profitable. If profit is your sole motive, you are doomed. Like, as a society, it won't work out. Anywho. Notes from Cartland says, invest in the ability of people making informed and good decisions, and better decisions will come. Yeah, but what does that mean? I don't know. I don't think I agree, Notes from Krautland. I'm sorry. I think I strongly disagree. Yeah. Dave Nevius says, why should I care if the world ends the day after I die? Sounded like a Bond villain there, you know? I don't know. I know you're being sarcastic. I appreciate your good humor there. Oh, yeah. Yeah. Anyway. Yeah. It's good to see you, sweetie pie. Let me get you some treats. And here, I'll share this link with you, everybody. Yeah. But with the ducks, this kind of gets into today's topic, too, talking about dinosaur reproduction and dinosaur courtship. Yeah. So, ducks and their genitalia are really interesting. Yeah. It's just interesting stuff on its face. And most of the grant money was spent on salaries, putting money directly back into the economy. Essential stuff, stimulating the economy, rather than just giving it to wealthy people who were squirreled away in overseas bank accounts. Instead, this is helping drive the U.S. economy. But yeah, to fully understand... Oh, genitalia, dear readers, are where the rubber meets the road evolutionarily. To fully understand why some individuals are more successful than others during reproduction, there may be no better place to look. That stands to reason. The importance of evolutionary research on other species' genitalia to the medical field has been recently highlighted in the Journal of Sexual Medicine, generating new knowledge from what factors affect genital morphology in ducks, one of the few vertebrate species other than humans that form pair bonds that exhibit violent sexual coercion. Oh boy. We have significant applied uses in the future, but we must conduct the basic research first. In the meantime, while we engage in productive and respectful discussion of how we envision a future for our nation, why not marvel at how evolution has resulted in such counterintuitive morphology and bizarre animal behavior? This is kind of like what... You know, Denver used to talk about this all the time when we'd be out there in the field. We'd be... I don't know, he'd be kind of bemoaning how difficult it was to get funding for a particular season's field work. Like, the hoops that he would have to jump through to just get $2,000 or $3,000 for us to be able to go out and dig up dinosaurs for a few months. Like, that's not a lot of money in the grand scheme of things, you know? There are companies here in the Bay Area that will spend $2,000 or $3,000 on a company dinner when they've got, you know, like a visiting CEO from another company joining them for an evening. And yet to go out and dig up dinosaurs for 2 months, to maybe excavate a new holotype specimen that'll be the first individual of a new species published. If we can do that for $2,000, that's nuts. And also, that $2,000, it's not like that disappears once it gets awarded in grant funding to a group of paleontologists. That money is going to be spent very frugally and will be distributed into rural communities struggling economically struggling communities in eastern Montana. That is paying people's bills. That is allowing for grocery stores and gas stations to stay open in these communities. I don't know. I remember when Denver got a grant, I think this was in 2012, we got a grant to relocate a bunch of Triceratops sites and log them stratigraphically. Like, it's really important basic research. And he's like, yeah, that $2,000 that we got for that, all of that is being spent on fuel, on supplies. All of that is going into these struggling rural communities in eastern Montana. What better way is there to stimulate the U.S. economy than in science funding, you know? Because not only are you helping stimulate those economies that are struggling, helping put food on people's tables, but also we're digging up fossil specimens that'll be displayed in museums. That generates tourist revenue in these towns too. And it gives other researchers from around the world an incentive to fly into those communities to study these specimens. And when they do that, they're staying in a hotel, they're eating at restaurants, they're paying for fuel and food and whatever else. I don't know if there is a better way to stimulate the U.S. economy than to spend money on science. You really have to be like a creationist level anti-science quack to oppose science funding in the U.S. To consider that a waste of money? No, there's ulterior motives there. There's something else going on. It's nefarious. So it's deeply, deeply distressing what is going on in the U.S. government currently. It's... I don't know. I had reposted about this on Blue Sky today. Comprehensive and very bleak summary of the current state of U.S. science. Things are bad right now, folks. They're really, really bad. U.S. science in chaos as impact of Trump's executive orders sinks in. It's not good. It's really not good what's going on right now. And if you know any other scientists personally in your own life, aside from me, check in on them right now. Because at the same time that queer folks in our country are being persecuted in the same way that they're really scared right now, maybe not to the same extent. I'm not trying to draw an exact parallel and say that we as scientists are persecuted in the same way, because we're not. We've got a lot of privileges. But science is being attacked at the same time that queer folks are being attacked. And it's a bad time in the U.S. to be a queer person or to be a scientist. This is the same sort of thing that we saw in Germany in the 1930s. And it's happening here in the U.S. right now. It's not good. It's really, really not good. Anywho. Sweetie Pie, let's get you some treats, huh? I know you want that right now, huh? Yeah. Let's make that happen, then we'll get back to our Valentine's Day topics, huh? Yeah. 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 Let's get you some treats. Would you like that? Would you like that? And holy cow, Desert Flannel.
If they're removed, America loses them forever.
I love your name. Welcome to Paleontologizing. It's good to have you here. Thank you for the Prime. Or no, that's not a Prime sub. That is a recurring sub right there. Thank you very much for it. I appreciate you. I appreciate you, Desert Flannel. Holy cow! Here, Sweetie Pie, let's get you some treats. Yeah, here we go. Ooh. Oh, how's that? Oh, Sweetie Pie. Good stuff. And that's not how queerness works, Krautland. It doesn't have anything to do with rationality. It's just, if you're queer, you're queer. I don't think you really understand how this works. Anyway. Yeah. I don't know. I'm not an expert in sociology. This is not my area to really comment on. But yeah. Okay, fair enough. Let's get to our topic about Valentine's, shall we? Valendinos. Here. Oh, and also I gotta post to Blue Sky too, so we'll do that. I'm tempted to say post a tweet to Blue Sky. Twitter is dead. Long live Blue Sky. Yeah. But yeah. You missed my post about buying you your book. What was that, Krautland? Shoot. What was that about? And thank you, Go-Go Nutty, for the 100 bits. I appreciate that.
Nice kitty.
Buying me my book. That wasn't the, on the wish list, was it? Seems the books are still on the wish list. But yeah. Die Welt, in der wir leben. I can't say I know what that is. I'm not a German speaker. Or even a German reader. But, CAPTCHA, what is this? Translate to English. Yeah, huh. I'm not familiar with this.
If you're feeling a bit cheated, try blaming the dinosaurs.
As someone who lives in shorts and short sleeves, how have you not melted yet, Danny?
Niffler, I've got a powerful fan blowing air at me right now. And if I didn't have gel in my hair, you'd probably see it blown around a little bit.
For the science.
And thank you, Flug, for the 100 bits. I appreciate it. Yeah. And I am wearing shorts right now, by the way. Look. Yeah. That's the key to my survival at the moment, Niffler. But fair question you asked. It was I had to consider the very same thing. Yeah. Oh, the world we live in by life. Oh, very nice, Krautland. Okay, cool, cool. Yeah. Good stuff. This is very much an antique book. It's very out of date, but it was very influential for a lot of paleontologists apparently, and some people here in chat too. Yeah. And Claire, what is this? Someone found one of your shorts and posted it on Blue Sky. What is this? Oh, yeah, we know this person. Yeah. Yeah, I've liked this before. Yeah, good stuff, Claire. Yeah, that reminds me. Let me, let's do a Blue Sky post here. And thank you, Hogan, for the 300 bits. Yeah, and, then we'll get on to our Valendinos topic. I kind of doubt we'll get to Thursday Birthday today. I don't suspect we'll have enough time, but we'll see. This is gonna look ridiculous, so be forewarned. But, yeah. Golganek, thank you for the 100 bits there. Lovely. Appreciate you, Golganek. We're approaching a level 1 hype train here. Beautiful. Something tells me we're not going to get our sub goal for the week, given that this is our last stream of the week.
If you're feeling a bit
we'll
cheated,
see.
try blaming the dinosaurs.
Sculpin, thank you for those 100 bits. Yeah. I look worried right here. So let's try that again. There we go. This is so stupid.
In all the world, there are fewer than 40 full-time dinosaur paleontologists.
Hogan, thank you for the 5 gift subs there. Thank you, Hogan. Excellent.
3 of them are leading this expedition.
Good stuff. Thank you, Hogan.
698 just gifted 5 subs.
Appreciate that, Hogan. There's 5 lucky chatters who won't have to watch any ads for the next month. And Flug! Well, serenading us here. Music to my ears.
Flug really wants ukulele with those 5 gift subs.
Thank you, Flug, for the 5 gift subs there. Brilliant. I appreciate it, Flug. We're at 73 out of 198. Yeah. Alright, try a bit of a smolder. We'll see, Charlie's Dragon. Okay. Here. I can't close my lips over it. You have to, like, kind of be baring your teeth a little bit, which I realize in a lot of species is seen as a threat display. So there's a fine line to be walked here. Let's see if this is any better. Oh. Sure, we'll go with that, just because it looks really stupid. And I think it's funny. Here we go. Yeah. Let's post that. And Haraz, thank you. Holy moly. 10 gift subs there. I appreciate it, Haraz. Thank you very, very much. Welcome, not welcome. Welcome back, but thank you for your incredible generosity. And oh, shoot.
Harsh is overloading the system with 10 gift subs.
Hold on to your butts.
Thank you, Haraz. I like how Harsh is, that's how she pronounces it. Our text-to-speech speaker there. Is that how you intended it? I've always said Haraz, but is it Harsh? I actually like that a lot better. If it's Harsh, let me know, and I will say it that way from now on, because that's, man, that sounds cool. Yeah. Just Haras. It's a purely made-up name. Okay, cool. Cool. I almost wonder if that coincides with the name in other languages. Hogan, thank you for the 200 bits. Brilliant. That just got us to a level 4 hype train here. Beautiful. Thank you for that. Excellent. All right, let's post a new post. Happy Valentinos Day. About to discuss dinosaur hearts. Dinosaur courtship. And how in the world we can surmise these things from the fossil record. Right now on Twitch. So come join us at twitch.tv/paleontologizing. Twitch screenshot of some goofus holding a plastic rose between his teeth with a Protoceratops skull. Stegosaurus model and some goofus wearing a doofy smoking jacket and holding a plastic rose between his teeth. Various bits of framed dinosaur paleontology ephemera on the office wall behind. There we go. All right, looks good.
Hold on to your butts.
Let's post it. Nice. Yeah. Okay, good stuff. There is a link. If you'd like to engage with that post for whatever reason, whether it's to share it or like it or heckle it in the comments, there you go. Do what you will. Been struck by a smooth dinosaur. There you go, Gravity, yeah. The smoothest of dinosaurs. Like, Very smooth indeed, like a... Wait, hang on. No, Scutellosaurus isn't very smooth. Oh, she looks pretty bumpy. Smooth. How about, struck by a smooth dinosaur like Jacob... No. Hang on. Smooth. How about, smooth dinosaur... No. Why do I keep picking Thyreophorans? Let's choose sauropod. They're nice and smooth, right?
I can see that my 50,000 a year has been well spent.
Oh, shoot.
Is this Playboy After Dark? Pally is not like this.
Zook, I think you've got the wrong chat, but thank you for the 8 months of support. Appreciate you. It's good to have you here. Again, not very smooth. Well. Yeah. Plucked goose. Oh no, Jody Fish. I don't think the geese would like being plucked very much, so I'm gonna avoid that. Yeah. And Harash is indeed a surname of Polish origin, by the way. Is it really Scorch Hellfire? That's pretty cool. Anyhow. Let's talk about dinosaur hearts for a minute. Those of you who were here at the very beginning of today's stream, you probably saw this. You probably saw this little dinosaur. Thessalosaurus. When I was a kid, this was a big deal. This particular fossil specimen, which I think is still at the North Carolina Museum of Natural Sciences. All right, we're officially getting into our Valendinos theme here, so let's get ready for that. The world's first dinosaur with a fossilized heart is now on display at the North Carolina Museum of Natural Sciences. Bingo, I got it. The 66-million-year-old fossil could change what we know about dinosaurs. Nicknamed Willow, North Carolina scientists uncovered the 600-pound, 13-foot-long Thessalosaurus in South Dakota in 1993. Willow was named for the wife of a rancher on whose property the remains were found. Her name was Willow? Really? What made the find so special was a grapefruit-sized object found in the dinosaur's chest cavity. It turned out to be a heart, complete with ventricles and an aorta. Yeah, and it's Willow with only one W, Crimson Carnotaurus. Yeah. Creatrix Brit says, amazing, well not so fast. Because it was later very much disputed. But, yeah. Oh, goodness. Scientific American. I have a subscription. Why are you... Where do you subscribers sign in? Maybe we'll just ignore this for now. That video's gone now. Oh, hang on. Now here we go. Bingo. Well, medicine didn't invent the machines. Engineers did, but... Yeah. And you know what they say, when life gives you gators... What happens when life gives you gators, chat? There you go, Britt. Bingo. Krautland, yes. Oh. Yeah. And hang on a second. First time chat, let me pause right here because it's a really important question. From Aaron Vonderberg. Would you be willing to share what undergraduate and graduate majors to focus or recommend to pursue a career as a paleontologist? Absolutely. Yeah. Paleontology is one of those fields that's pretty small. And so if you're in a school that offers paleontology courses, take those. But most schools don't offer paleontology courses. So what do you do? Paleontology is this really interesting mix of biology and geology. So really take as many biology and geology courses as you possibly can. So within biology, that'll be basic biology, maybe molecular biology, things like zoology, botany. Comparative vertebrate anatomy is one of the most important classes you could possibly take if you want to like study dinosaurs, for instance, like I do. Comparative vertebrate anatomy. Here's an excellent textbook on the subject. Vertebrates, Comparative Anatomy, Function, and Evolution. This was my primary textbook when I took CVA, Comparative Vertebrate Anatomy. Back at Montana State. But also, I don't know, a lot of paleontologists, in order to make a living, they might teach human anatomy, or they might teach her at a veterinary college or something like that. So anything that you can, any classes that you can take related to animal anatomy, if you want to study fossil plants, study plants, stuff like that. That's within biology. Within geology, any geology courses you could take, especially related to sedimentary geology. Because fossils tend to come from sedimentary rocks. Rocks laid down by ancient rivers and streams and creeks and lakes and oceans. Sedimentary geology. That's the kind of geology that paleontologists focus on. Those are the rocks that we find our fossils in. But apart from that, like I said, I think yesterday, the best piece of advice that I can give for somebody who wants to become a paleontologist is to start hanging out with paleontologists. If there's a museum anywhere near where you live, see if you can start volunteering at that museum. Or if you can't afford to volunteer, like I know a lot of people can't. I could barely afford to do that when I was starting off. If you can get a job in the museum as a custodian, or working the front desk, or working in the gift shop, or whatever, just being there in the museum where the action is, where you can hang out with paleontologists, you can spend some time in the laboratory maybe, you might be able to get yourself a spot on the crew, out doing field work, that kind of thing. That's the most valuable piece of advice that I can give you, is get yourself into a museum. That's how I got my start, back when I was in high school. I started working at the Museum of Paleontology in Berkeley. And, yeah. So I hope that makes sense. Yeah. And a natural history museum, not an art museum, obviously. Yes, a museum that has fossils and has paleontologists working there. Although, if there isn't a museum like that where you live, maybe the next best thing is working in another kind of museum, because if you move to a place that does have a museum with fossils, it might be easier to get in there because you can say, hey, I've worked at this other museum. I have museum experience, even if it's an unrelated kind of museum. You know? So yeah. Sweetie Pie, you are incorrigible. Again, Sweetie Pie just being extortionary. Even. Sweetie Pie saying, oh, well, you know, it's, awful nice stream you got here. It'd be a shame if somebody, just stood in front of the camera so that you couldn't reach your audience, you know? It'd be a real shame. You know, we could see to it that this situation could be avoided. Were there to be, say, a payment of some cat treats that were to be made. If there were an offer of some treats to be made, then perhaps this unpleasantness could be avoided. All right, Sweetie Pie. Okay, sweetie. Okay. Here you go. What, do you not see? Look. Oh. What, is that not enough? Sweetie Pie, please. Please, I have bills to pay. Please, be understanding, sweetie. Please, Sweetie Pie. I offer you what I can. Yes, please, accept my offering, Sweetie Pie. Only that many on her daughter's weddings, Dinodax? Apparently. Yeah. Oh. Oh, Sweetie Pie. Is that some tasty organized crime? Organized crime. Yeah. Good stuff, Sweetie Pie. You satisfied? She says, yeah, next time don't be late. Next time I will not be so understanding. Reminds me of this. Oh, sorry. I hit the keyboard. It's a Sweetie Pie here. Yeah. That's pretty much Sweetie Pie right there. Where were we? Oh, yeah. Alligators. And,
At the North Carolina College of Veterinary Medicine, an alligator is due for a CT scan.
I love gators too. They're very cool. So, the reason why we're looking at an alligator right here is that alligators are often used in what we call the EPB, the extant phylogenetic bracket. So if there's something about dinosaurs that's unknown, like what kind of hearts did they have? Well, we can look at their close living relatives. Birds, who literally are dinosaurs, we can look at what their hearts are like. And crocs, who are like cousins to the dinosaurs, we know what their hearts are like too. We can look at them. And so we can use these two different groups to kind of make inferences about things that are unknown for dinosaurs. Again, this is the EPB, the extant phylogenetic bracket. Does that make sense? Let's hope the Mafia and Valentine's theme of today don't get too close, says Crimson Carnotaurus. Uh-oh. It just made it worse. Because, why do we call it Valentine's Day? Because of the St. Valentine's Day Massacre. A warning! This motion picture depicts without flinching the most shocking event of America's most lawless era. The St. Valentine's Day Massacre. So yeah, as you can see, it's all connected, you know? Yeah. Anyhow. That's why we're talking about alligators. Thanks, Dr. Irrefutable. This works on me too, by the way. I remember that Crimson Carnotaurus, yeah. Oh, with the Tommy gun, yeah. Correct. So this is from the documentary Allosaurus, The Ballad of Big Al from the BBC, Walking with Dinosaurs spin-off. Yeah. Willow. So that's Dale Russell right there, who actually published a paper on this. There's the skull. Again, this is why this was at the beginning of today's stream. In case you missed it, this is our opening screen. Because that's the specimen right there. Willow. This was a big deal in the 90s. I remember this from when I was a kid. It's since kind of been forgotten, but, yeah. Here.
Plant-eating dinosaur. We call it Thessalosaurus in Paleontology.
Oh. tubes. Huh. Nice. So, yeah, right here. Yeah. It is Kenneth Branagh. Yes, indeed. Hmm. That would make sense. Yeah. Interesting stuff. Yeah. That's, of course, from The Ballad of Big Al, Allosaurus Walking with Dinosaurs special. Since then, that heart has been disputed. Riley Black's got an article about this from 2011. Willow the dinosaur loses heart. What made Willow special was its heart preserved inside a concretion cradled within the dinosaur's ribcage were the remains of a major cardiac muscle, but not everyone had been in agreement that Willow had a heart at all. Though discovered in 1993, Willow's major public debut came via a science paper published in April 2000. Written by Paul Fisher, Dale Russell, who you saw in that video, and colleagues. The study concluded the iron concretion in Willow's chest were the preserved remnants of a 4-chambered heart. Overall, the heart of this Thescelosaurus appeared to be more bird-like than reptile-like, a finding that has important implications for studies of dinosaur physiology. If dinosaurs, even those distantly related to birds, had avian-type hearts, they probably had bird-like metabolisms too. But anyway, later on there is a paper published calling this heart hypothesis into question. Actually, there were 2 papers about this. Yeah. Tim Rowe, Earl McBride, Paul Serena critiqued the other team's analysis in the same journal, concluding the object is not a fossilized heart, but an ironstone concretion that only superficially looked like a heart. A study just published in Nature Wissenschaften by Timothy Cleland, Michael Stoskopf, and Mary Schweitzer throws new support to the contentions of Rowe and other paleontologists. The organ is really a concretion, they say, formed when sand was washed inside the body and became cemented into place. There's one surprise inside the concretion. Although Willow's heart was not preserved, Cleland and co-authors found several scraps of cell-like material. These may have come from plant debris washed into the skeleton, or they might have come from the dinosaur itself. Perhaps, the scientists hypothesize, the decaying body of the dinosaur triggered the beginning of the concretion formation, and some of the sand formed around the rotting tissues before they had a chance to fully decay. So I want to say, because I've talked with some other Thescelosaur researchers about this since, and you might have had kind of thesis, antithesis, and then in between afterward, synthesis afterward. Where it could be that it's not actually a preserved heart, but that concretion may have formed because of an iron-rich organic blob there that was the heart. So it's like, it's not the heart itself, but because the heart had been there, you got this concretion that formed in its place. that hasn't been published yet, to my knowledge. So I'm just kind of giving you a rumor at this point. But yeah. Anyway, so a heart mold, so to speak, kind of, Coughlin's Wharf. Yeah, maybe. Yeah. So yeah. Anyway, Mini Pie, how are you doing? You heard there were treats to be had here, huh? Man, we're having rival gangs show up. Mini Pie here is like, So I heard that Sweetie Pie and her associates had paid a visit recently. I hope you remember our agreement. Says, I hope you remember the agreement that we had made in order to preserve peace and security here at this establishment. Yes, Mini Pie, yes. I will make sure that you get some treats too. Would you like that? Would you like that? Yeah. Okay, Mini Pie. Look there, wow. 3 treats. She doesn't know how many Sweetie Pie gets. And Mini Pie often doesn't eat all of them anyway. Yeah. Oh, what's that? Another one. Oh, good stuff. Yeah. Good stuff. Good stuff, Minnie. Yeah. Aw. Do you want more? What are you doing? Well, she hasn't left yet. I think she might want some more. You want some additional ones? Okay, we can make that happen. There we go. Yeah. But Minnie, I already paid your associate earlier. Yes. I am not concerned with the payments that you have made before present. These payments must be made post haste in the present moment. Oh, yeah. Oh, you're just gonna hang out here? Okay, that's fine. As long as you're not in front of the camera. As long as you're not blocking the camera. So anywho, yeah, Willow, the little dinosaur with a heart. This, oh, that's... Charlotte, that's wonderful. Abatha is enthralled with your content today. Well. It's awesome to see me on a TV. Wow, big screen. Big screen there. That's fantastic. I like that a lot. Good stuff. I just taken a large sip of coffee when you first came on screen today, and it almost came shooting up my nose. Thanks for that. Good stuff. Please post that link. I already did, Claire, but here it is again. Yeah. There we are. There. Big screen. Ooh la la. And thank you, Claire. Appreciate that. Yeah. Walking Stick Library says you need to do a cat stream. What do you think this is right now? Is this not a cat stream? Is this not a cat stream? Oh, it's a Valentine's cat stream. Look. Here's a rose for you, Mini Pie. Yeah. What are you being all scared for? You're the least scared of all the cats. You got a rep to maintain, Mini Pie. What's up with that? Where you going? Alright, I'll see you later. Where were we? Oh yeah, dinosaur hearts. Let's get back into that and then we'll get into dinosaur courtship and what have you. Take a look at this. From Irutan. Now, I've got to reverse this because the nature on PBS will sometimes, like, stuff will get automatically copyright struck on YouTube, so when this VOD goes on YouTube later, I've got to reverse everything and then cut the audio out. So this scene that I'm in right now automatically cuts out the audio. So if you're watching this on YouTube later, sorry, no audio for this portion, but this is what we got to do. So this is not Thessalosaurus right here. This is a Titanosaur. This is the dinosaur that that nowadays we would call Patagotitan. So this dinosaur here, which is it's on the large side as far as dinosaurs go. This is what we would call to use a scientific term, this dinosaur is big. It's one of the very largest of the sauropod dinosaurs. If you're to visit the Field Museum in Chicago or the American Museum of Natural History in New York, you can see a replica skeleton of this dinosaur on display to get a real sense for how big it is. A chonker in Latin. There you go, Kachira. Yeah. Yeah. Big boy, says Neverwinter. Yeah. Yeah. Can you explain big in non-science terms? Well, you know what lil means, right? So picture something that's lil, except it's not. Except it's large. That's this animal here. So you know how elephants are big and whales supposedly are big? This dinosaur is bigger than that. Not only is it significantly longer than something like a blue whale, it's also significantly heavier than a blue whale. Because blue whales live in the water and they're essentially weightless. This is a dinosaur that lived its entire life on dry land, so far as we know. Maybe they would have gone into water occasionally, just for fun and what have you, in the same way that many of you in chat do too. But this is very much a terrestrial creature. And so, unlike whales, who are kind of by definition weightless, this animal supported its entire body weight on land. And it's big. It's a big animal. It's a big animal. And thank you, Ordos Bassist. I appreciate that. Appreciate that. Thank you, thank you. Yeah. Let's continue. So again, it's Valendinos right now. We're talking about hearts, at least for the moment. This animal would have had a pretty big heart. Bigger than that of a Grinch, certainly. Yeah. Big-hearted dinosaur. Very generous. I bet most of you in chat don't even have a heart that's 6 feet in circumference. Not in diameter, but in circumference all the way around. That's pretty big. Wow. Pretty nuts. Crazy. So it's kind of the opposite of a hummingbird, who has an extraordinarily small heart. And a hummingbird's heart beats something like, it's many, many times per second. This is a dinosaur with a much larger heart that beats about once every 5 seconds, probably. We don't have a fossil heart from this animal, but just based on the sheer size of its skeleton, you can start to run some calculations and come up with estimates for the size of its heart, the liter of blood pumped by every pump, the frequency at which it would pump, all of that stuff, you know? It's, yeah, that's nuts. That's really nuts. What's really cool to think about is that the smallest dinosaur that ever lived, Melisuga helenae, smallest dinosaur that ever lived as far as we know, that's right here. The bee hummingbird. Both this dinosaur and Patagotitan, that huge titanosaur, they're both members of the same dinosaur group. The same half of the dinosaur family tree, Saurischia. The so-called lizard-hipped dinosaurs. Theropods and sauropods. This is a theropod. Patagotitan is a titanosaur sauropod. They're both part of the same half of the dinosaur family tree, which is kind of crazy to think about, you know? Yeah, this is not a big critter. I bet you most of you in chat can't even stand on the eraser of a pencil like that and have it support your full weight. I'm sorry. I apologize if that's not as amusing as I think it is, but I really like to shame chat sometimes when we're comparing the anatomy and the size of the dimensions of various dinosaurs. You know? I bet most of you don't even have teeth that are 11 inches long, even if most of that is root, you know? Yeah. Do better, chat. Yeah. Thank you for reminding me I'm human, Dan. You bet, Dr. Irrefutable. That's why you come here, right? Yeah. Skill issues, says this one. Yeah. I don't know if it's ever been done, but I'd love to do a motion GIF image of a titanosaur and a hummingbird together. Someone did an illustration here. That's actually really nice. Well, yeah, a titanosaur and a hummingbird. Largest dinosaur and smallest dinosaur. Yeah. But like, the idea is you start at the hummingbird and then you zoom out to the titanosaur and then you zoom back into the hummingbird. I think it would be a really neat image. It would be too detailed for an emote, but I think that would be fun. But yeah, these are both members of the same clade. Saurischia. So-called lizard-hipped dinosaurs. That includes sauropods and includes birds. So yeah. Yeah. And Komodish says, is it true that at one point scientists attached, I don't know if surgically, wasn't surgically, they clamped it on. Small wooden pole to the tail of a chicken to study dinosaur walking? You bet, yeah. Here, I can show you a quick clip of that. Here we go. So there's the chicken walking normally. And here's the same chicken. I think it's the same chicken. With its tail with a... you know, like dinosaur tail-like prosthesis attached to it. To kind of study how the gait of the bird changes. Dinosaurs and their modern descendants, birds, they do walk in very different ways. Despite being bipedal, despite having the same kind of foot morphology and everything else, in a lot of ways, the tail musculature really changed. That's... with non-bird dinosaurs, they've got this muscular and bony tail coming out posteriorly to the hips, and there's various muscle attachment points for that. There's the big caudofemoralis muscle that stretches to the femur bone and all this other stuff going on. In order to try and model what that would be like, one of the ways that you can start to do that is to slightly change the gait of a modern bird like a chicken by attaching some weight to the tail and just seeing how the posture and everything changes. It does change the center of gravity, absolutely, Jazzy Cat, yeah. Yeah. Good stuff. Mizart Rule says, what came first, the chicken or the egg? Animals have been laying eggs for literally billions of years before the first chicken evolved, so eggs definitely came first. Yeah. Guess what? Experimental chicken butts, says Steely Dan. There you go. Yeah. Good stuff. Yeah. Anywho. Yeah. Anywho. So I'll give you a link to this right here. Komodish. And let me see if I can find you the paper. Here it is. In the journal PLOS One. Oh wait, no, shoot. Where'd it go? That's not right. That's it there. Walking like dinosaurs, chickens with artificial tails provide clues about non-avian theropod locomotion. PLOS One is an open access journal, so there is no paywall here. Yeah. Gotta love it.
Access granted.
Good stuff. So you can read this to your heart's content. Very short article here, but really cool stuff. Anywho, I hope that satisfies you there, Komodish. It's neat stuff. This is a really cool study. Yeah. Void Game Hater says, I am highly skeptical of what we can learn from this article. Well, I assume you have read the entire thing, cover to cover, before you make a blanket statement like that, right? I presume that you're already well familiar with the articles cited and the references, and you're not just saying that without having fully delved into it. Right? Right? Void Game Hater says, fair blanket statement. Yes. But chickens did evolve to not have long tails. It hardly applies to apples, no? Well, that's the thing. If we don't have living non-bird dinosaurs to study their locomotion. We can look at trackways, and we can look at the skeletal anatomy, the osteology of extinct non-avian dinosaurs. But if we want to get a peek into how they would have actually walked, how their muscles worked and everything, our best bet is to look at modern birds who lack some of this musculature and they don't have the same center of gravity. So the best thing that you can do is to tweak them a little bit. If you change their center of gravity, you can look at how they compensate for that. So it's a nice start. Does that make sense? That's what's outlined in the paper, you know? Chickens raised wearing artificial tails and consequently with more posterior located centers of mass showed a more vertical orientation of the femur during standing and increased femoral displacement during locomotion. So this is something that we've long assumed would be the case. Given that birds today, the way that their femurs are oriented is kind of crazy compared to what we see in, you know, in dinosaurs. So the femur of a chicken, here, I'm trying to find you a... That'll work. Yeah. Look at the thigh bone there. See how it's almost horizontal? It's only inclined a little bit like that. This is very different from like a non-avian theropod dinosaur like Velociraptor or Allosaurus or T-Rex, for instance. And we think that that's probably because dinosaurs, like I just mentioned, have got long, bony, muscular tails stretching behind them. But again, that's still just kind of an assumption. So how do you test that? Science is about testing ideas. So one way of testing that is to see, how does the gait of a chicken change? How does that posture change? How does the way that it holds its thigh bone change when you put some weight on its butt? When you put a little bit of weight, like a long bony tail, on its rear? And sure enough, you can even see that in the, well, I think they did this like in front of an X-ray camera too. But the gait changes. The femur becomes more vertical, more up and down, like you see in like in a skeleton of, say, Allosaurus. That femur is going more vertically, like in a non-avian dinosaur. There's Big Al right there, yeah. So it is really cool stuff. It's a prediction made and tested and confirmed. That's some solid science. So yeah, I hope that makes sense. Yeah. And it's a good test as well. It's basically an engineering/mechanical test, says Gojira. Yeah. Yeah. Anyhow. Yeah. And did dinosaurs move their heads like chickens and pigeons do? That's a hard one to test, I think. How do you use the fossil record to try and figure out if dinosaurs would have bobbed their heads as they moved? I don't know enough about bird motion and cognition and vision and everything else to say exactly why they bob their heads as they move, and only certain birds really do this. I've heard it said that this is a way to like focus on different objects. There are a lot of birds that have got kind of like a gyroscope thing going on where you pick them up and you tilt their body around and their head will stay in place as they're doing this. Yeah. You know, like this. I don't think all birds do this. But I don't know what it is that allows them to do this in the first place. Is it something in the inner ear? Is it something to do with balance? Is it primarily birds of prey that do this? I mean, chickens kind of do this too, and I think pigeons might also. So I don't know. I don't know how you would test for this in non-bird dinosaurs. So yeah, bird was made by DJI. There you go, Krautland. Yeah, yeah. It was pretty wild. I don't know if you could do this with an Allosaurus. I mean, it'd be a lot heavier. But, yeah. Nature Study Camp says this one. Yeah, yeah. So I don't know. I don't know. I don't know enough about birds to really answer that question in a way that I think would be satisfactory. And Charlie's Dragon says the head bobbing is to stabilize their vision, like taking a snapshot. Quickly move their head. New snapshot. But why is it that certain birds do that and other birds don't? Or do all birds do that? It just looks different in different birds? I don't know enough about that. And I don't know what kind of osteological correlates you would have for that. In other words, is there something in their skeleton that allows for that? The birds that do that, is there something special about their inner ear or their skull or their neck vertebra or something like that that would be preserved in their skeleton that we can look for in non-bird dinosaurs or even in extinct bird fossils? I don't know. I don't know. It's a good question. Yeah. So yeah, and is it more in predatory birds than other birds? I don't actually know, Makeaway. I don't know about that. We don't think of pigeons as being predatory birds. Although pigeons will eat other critters if they get the chance. I've seen a pigeon eating a dead rat before. I don't know if the pigeon killed the rat, but it was eating a dead rat. A rat that got hit by a train. Yeah, I don't know. I don't know if it's more common in predatory birds. Insectivores are predators, says Gojira. Yeah. Yeah, you can make that argument. Yeah. And bread loaves say otherwise about pigeons being predatory. There you go. Yeah. I've heard that chickens will snatch up and eat mice. They absolutely will, Charlie's Dragon. You don't often think of chickens as being predatory animals. But, yeah. This is, here, if you're you might want to tune out for about a minute here if you're very, very fond of mice in particular. I like mice. I don't particularly like to see any animal get devoured. This is really fascinating seeing a chicken do this. Take a look. So here's a cat playing with a mouse. And then in runs a chicken here. Watch this. Wow. Yowza. And I've seen videos of chickens just swallowing mice whole, too. It really is. It just runs at it like it's a theropod dinosaur, because it is a theropod dinosaur. It's like a tyrannosaur. Just run over there, just shake this thing to death. Yeah. So yeah. Yeah. So anyway, a lot of birds will be birds of prey if you give them a chance, you know? For instance, here, pelicans will swallow capybaras whole. Take a look at this. Well, they'll try anyway. These capybaras are a bit too large. But they'll try. Yeah. Haven't seen them eat a seagull, though, says Mark Melvin. I mean, they'll eat pigeons and stuff, yeah. Pelicans, if they can fit something down their gullet, they'll eat it. You know? If you were a person who was 7 inches tall running around through a bunch of pelicans, they'd probably eat you. Yeah. Yeah. Anywho, let's get back to David Attenborough in the Titanosaur heart here. Here, we'll start at the beginning. Jeez, that's a big heart. Probably the biggest heart of any land animal that's ever lived. Nuts. Yeah. Oh, and that's it. Okay, cool. Anyway, that's the point. Big heart. And what is this? Yeah, pelicans will also swallow giraffes whole, full-grown giraffes. They'll try at least. That's great, Murph. That's great. So here we have dinosaurian predation on super large mammals. Unsuccessful predation, but you know. That's great. Good stuff. Yeah. Anywho. Let's jump into a little PBS Eons video here about not dinosaur hearts, but a different aspect of Valentine's Day. Courtship. How did dinosaurs couple up? Let's take a look at this lovely video from PBS Eons from 3 years ago. Starting off with a good still here of a modern dinosaur.
Animals today do all kinds of different things to try to catch the eye of a mate. Some male
Here, I'll be right
mammals,
back.
like deer and bighorn sheep, literally butt heads to compete for females. Other male mammals do things like post pictures of themselves holding fish on social media. Lizards flash brightly colored neck flaps and bellies. And birds, of course, sing, dance, and even build and decorate elaborate structures made of twigs and rocks to win hearts. But what did the non-avian dinosaurs do? You know, the extinct ones. Dinosaur mating behavior has been the subject of a lot of speculation, including by me. But what we can actually say about it from the fossil record has been pretty limited. It would take the description of a new kind of fossil in 2016 to give us a peek into that part of the lives of these animals. The fossils were the 98-million-year-old traces left by big theropod dinosaurs.
Pretty cool stuff. Whoop. No, I wasn't trying to do that. I wasn't trying to turn the volume down to 0. Oh, boy. Anyway, I'll be right back. I gotta run to the bathroom. But this is super cool. Fossil evidence of dinosaur courtship in footprints, or rather, scratches. A preserved dinosaur dance floor. Super neat.
Left by big theropod dinosaurs, cousins of the famous T-Rex and Velociraptor in Colorado. And they didn't really match the fierce reputation of most theropods. So prepare to learn what little we know about dinosaur sex. I'd rather you hear it from me than like on the playground or whatever. Dinosaur mating has been on the minds of paleontologists for more than 100 years. It's been on my mind since I first learned what a cloaca was, and I'll get back to that in a minute. But scientifically speaking, we know that dinosaurs did it, but we don't really have a lot of evidence for how it all happened. Like on the Tree of Life, dinosaurs are close relatives of crocodilians
and so this is... I want to remind everybody, just real quick here, a gentle reminder, that this is intended to be a PG-rated broadcast. All ages appropriate. So whatever body remarks you're thinking of right now, maybe keep them to yourself. Yeah. Just be cool, you know. Let's follow the rules for the channel and all that. But yeah. Let's continue.
And birds. So they probably shared some of their reproductive anatomy and behaviors with these two groups. When we make inferences based on evolutionary relationships like these...
This is called phylogenetic bracketing. Yes, indeed. This is the EPB like we were talking about earlier in the stream. Good old EPB. If there's something that's unknown for dinosaurs, we can look at the critters that bracket them, their closest living relatives. Crocodiles, who are kind of like cousins to the dinosaurs. And then birds, who are living dinosaurs. We can figure stuff out about them. We can just look at them. In order to make... to kind of frame our thinking about these unknowns for dinosaurs in ways that make sense. Phylogenetic bracketing.
It's called phylogenetic bracketing. And it's useful because it gives us a starting point for coming up with hypotheses about what dinosaurs might have done. But then we need actual physical evidence to test them. And that's where those fossils published in 2016 come in.
Yep.
A team of paleontologists was working in Colorado looking for dinosaur trackways in a geological formation that preserves a lot of trace fossils. These are things like footprints and other marks left behind by extinct animals. Now, trace fossils might not seem as exciting as a dinosaur skeleton, but they give us a window into the past because they record an organism's behavior.
So trace fossils actually are really, really interesting. There's something kind of magical about them. Because even though they're not part of the physical animal itself, they're not a bone, they're not a piece of a carcass, they're not a piece of the body of an organism. They're instead a record of the animal's behavior while it was alive. Which is really special in and of itself. You're not seeing the dead animal, you're seeing the animal in life, in a sense. And that's pretty special.
Now, we have found hints about mating behavior in the bones of some dinosaurs, like tyrannosaurs with bite marks on their faces, because those could be signs of fighting over mates. But they easily could have come from something else, too. But that site in Colorado was crisscrossed by dinosaur trackways, and there the team noticed some odd scrape marks on the ground. First one set, and then another, and then another. All told, they would find around 60 scrapes there. And it turns out this wasn't the only site like this. They'd also discovered 2 more close by in western Colorado and 1 in the eastern part of the state. And these scrapes were a whole new kind of trace fossil, one that had not been recognized before. They had a distinctive shape with a deep groove down the center, as if the maker had sharp claws on their toes. and associated with some of those scrapes were footprints with 3 toes. So this convinced the paleontologists that the tracks were made by theropods. But
yep, so from a theropod, kind of like Acrocanthosaurus, probably. Acrocanthosaurus, I think, is from around the same time.
Shapes and sizes.
Helishman JD, thank you for the follow. Welcome to Paleontologizing. Good to have you here.
Then they had to figure out why big, probably meat-eating dinosaurs would have been digging in the dirt. And they proposed 4 hypotheses. First, maybe the scrapes were nests or part of nest colonies. Now, we have found dinosaur nest colonies.
Oh, I know this specimen. This is at Museum of the Rockies. Those are Troodon eggs right there. Yeah, very nice. Look at how elongate they are. And they're kind of in pairs. We think that these dinosaurs had dual oviducts and, yeah. Troodon indeed, Claire Burr. Yes, indeed. Those are Troodon eggs.
Troodon colonies before, and we know what bird nest colonies look like. The nests tend to be a standard shape with regular spacing between them. Nests also tend to have eggshells in or around them, and sometimes the remains of unlucky hatchlings too. But the scrape sites don't have any of these things, so the researchers think they weren't nests. So okay, hypothesis number 2. Maybe the dinosaurs were digging burrows or looking for food or water. But digging doesn't seem to have been a common behavior for most dinosaurs. And the
maybe not, actually. Digging does seem to have been a pretty common behavior for a lot of different dinosaurs. Whether they're Oryctodromeus digging burrows, whether they're Thescelosaurus probably doing the same thing, or whether they are Leptoceratops digging burrows. I'm so glad I can finally talk about this. I thought I had to keep this under wraps, but those of you who saw the North Dakota streams caught a glimpse of this. Here we go. Nice. Let's go ascend. Thank you.
So one very big lembo we've had. I had an
Lepto there.
volunteer, Wes, who's now more advanced, but this was one of his first projects. This femur here.
Oh man.
That guy's in a thick fiberglass crate.
Anyway, let's get to. Let me get on this.
Bones, all sorts of things.
2012, you found it.
I found it in 2012.
Thescelosaur, yeah.
Yeah, we thought it was a Thescelosaur, but I presented about this here at our own conference, and you may have read a little bit in places, but we found a Leptoceratops bone bed, and we have remains of
Claire, oh yeah, they know.
All sorts of things.
Yeah.
1/3 size individuals, we have hatchling grade individuals. So these are part of an exhibit that we're putting together.
So Leptoceratops is this, I say little dinosaur, but it's not that little. Leptoceratops is a lovely horned dinosaur with no horns that lived at the very end of the Cretaceous period in the Hell Creek Formation. Denver calls them, what did he say? He said, like, horrid little pigs. It's like if a warthog had a giant parrot-like beak and it lived in a burrow and raised its young underground, which I guess warthogs kind of do, don't they? These are one of my favorite dinosaurs. They're pretty neat. Because I got to work at a really important site for Leptoceratops, one that showed us that these guys, I think it shows pretty clearly that they raised their young in burrows underground.
Showing a Leptoceratops burrow. These are animals that lived in burrows, based on some of the new information that we're basically putting together.
And I'm so glad we could talk about this because I've been super cagey about this on stream.
Well, I'd still be super cagey. I'm just doing like a little exclusive. I'm not going to go into any details, but you know what's in the abstract that we presented is already out there.
I didn't realize that. Yeah,
so. It's an exclusive for this, for when we did our own little meeting here. But we've had basically you can't get a skeleton of a Leptoceratops anywhere. I tried to find casts. Canadian Museum of Nature, Indianapolis Children's Museum have a closely related animal, but basically no one has the molded parts or the casts available. So we got 3D sculpts made of Leptoceratops, and we have these little skeletons, and I can produce some more of those. So that's going to be just a small part of this immersive exhibit that we're going to be building. We have some fleshed up models coming, some little
Very cool
surprises
stuff
for people in amongst all that as well. I hope it's going to set a new standard for the kinds of immersive exhibits that you can have in museums. Playing catch up on some of the exhibits.
Cut out. It's Starlink. It's not going to be perfect. But yeah, very cool stuff. I'm so glad I can talk about this now. Leptoceratops, a burrowing dinosaur. These guys lived in burrows. I can finally talk about it. Holy cow. Yeah. So anyway, digging behavior in dinosaurs, not only do we see it in the two-legged ornithischian dinosaurs like Eryctodromius here, digging burrows and raising their young, but we seem to see it in Thescelosaurus, in dinosaurs like Photna, which is also a close relative, and now in the leptos also. Does anybody... Oh. Nobody's really illustrated this hypothesis yet. I might have to do that. Or if anybody does any paleo art here in the chat, if you want to draw some Leptoceratops digging in or living in a burrow. Oh, there we go. We do have that here. Yeah. There's evidence that Leptoceratops raised their young in communal nesting burrows and even shared burrows with multituberculates. Well, shared them. Multituberculates are, living rent-free there. But yeah. Anyway, cool stuff. Leptos are such neat, underappreciated dinosaurs. They really are. Yeah. Good stuff. Totally making the poggers face there, says Ms. Argles. Yeah. So like a mole, not like a mole, but like a hyena, or like a warthog, or like a polar bear, or like other animals that dig burrows, but you don't really think of as like an underground animal. I'm not saying that these animals lived underground full time. That's not what I'm saying. These are animals that would run around and do their thing above ground. But, you don't think of foxes as being animals that live underground, but they certainly dig burrows. And they raise their young in burrows. A lot of mammals do this, and I think a lot of dinosaurs probably do this too, especially smaller dinosaurs, like Leptoceratops, like Thescelosaurus, like Eryctodromius, like Photna. Yeah. So not an animal that lives full-time underground and is mostly blind and everything. I'm not saying Leptoceratops is like that, but merely that they... We know at least, we have evidence at least that they raised their young inside of burrows. So I'll leave it at that. Yeah. Was a bald guy with a speech impediment hunting them? Those wascally Leptoceratops, Crimson Carnotaurus. I don't think so. No. And how big did Leptoceratops get? They get maybe about the size of, well, I don't know, like this. About that big. So about the size of like a Great Dane, maybe? Like a very large dog. Something like that. Yeah. But certainly not much bigger than that. Yeah. So about the size of like a really big hyena, maybe. Or for a very small, very, very small horse. Yeah. Like tiger size? I guess so, Ms. Art Rules, yeah. Or a Komodish, yeah. 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 Yeah, because I guess a tiger's not that much bigger than that. Most tigers are about this size, I suppose. So yeah, they do get about tiger-sized. I guess that's fair to say. Yeah. Leptoceratops. There we go. Yeah. So about 2.5 meters long. It's about the same length as a tiger. Probably not quite as heavy, but I don't know. It's got skinnier legs, certainly. But presumably a more powerful bite than a tiger. That beak is really something. And these guys may have eaten roots and stuff. Yeah. Yeah. Those legs look really skinny, says Claire Burr. I mean, you're kind of seeing them from the side, too, though. A tiger's legs would also look pretty skinny if you were to shave them, to be fair. That's one thing that I noticed with Moon Pie when she came back from her surgery, is that one of her arms is partially shaved so they could put the IV in there. And it looks pretty silly. Oh, there she is right there at the doctor's office, and this part of her arm had to be shaved to get the IV in there. And her arm looks so much skinnier without the fur. I bet you the same thing would happen with a tiger too if you were to shave its arm. In fact, tiger with shaved fur. No, I'm not really finding any good images. I guess their hair and fur isn't as long, proportional to like on Moon Pie, but anyway, a lepto like this, it's, you know, this would not be considered a small animal today, but by dinosaur standards, it's small. When you've got Edmontosaurus that's like maybe pushing 50 feet, Tyrannosaurus over 40 feet long when full grown. Yeah. Yeah. Anyhow. And Moon Pie is definitely continuing to recover, Jazzy Cat. Yes, indeed. We're taking very good care of her. Yeah. Dr. Irrefutable says it's pretty good size, though? I guess. Yeah, but this is tiny compared to some of the other animals in that ecosystem. Like, shoot, let me go get the T-Rex skull that I've been working on. I was able to put some more pieces on together this morning. Let me go grab that. This is not even complete yet. Still adding more pieces to it. But this is just the skull of Tyrannosaurus right here. And it is enormous. Struggle to even fit all of it in the frame. It's really big. It's really, really big. And again, like the back third of it isn't even on yet. So, assembly continues. Is it heavy or just cumbersome? It's both, Kettle Cook. It's both. So, we'll put this back where it was. Oh, shoot. So big it's knocking my lights out of whack. There we go. Crisis averted. Yeah. Anyway. Yeah. And how many kilos of filament will the entire T-Rex skull be? I think about 20. About 20 kilos. Yeah. It's a lot of filament. And there's one piece that apparently I missed. I had to cut one of the larger pieces in two in order to get it to fit on the print bed, and I'm not sure I printed the second half of it. So I'm printing that right now. And once that is done, I'll be able to fit some other pieces on, because it's one of those in-between ones that I need to put in first before I do the ones behind it. So, yeah. Total print time, Krautland? I don't know. Probably about 2,000 hours of print time? 2,000 or 3,000 hours? Yeah, and that's with a 0.8 millimeter nozzle. So that's with an extra large nozzle. Yeah, and 20 kilos of filament. Well, they cost $26 a kilo. So 20 times 26, that's $520 plus tax. So yeah, it's big. Will I be able to move it through the door entrance? Yeah, I took some measurements earlier. I don't have, I'm not worried about being able to fit it out the door anymore. It should be able to fit. Barely, but it should be able to fit. Yeah. So it's like 90 when you print the whole thing. 90 what, Murph? 90 kilos? Anyway, is it less awkward than a sofa? It's got sharper teeth than a sofa does. For sure. But, I should be able to carry it myself, just one person. And load it into the car to bring it to its forever home at the museum. Again, this is, I'm actually hoping to go there tomorrow. And it would be really nice if I have the whole thing assembled before tomorrow so I can at least show it to the museum director. But this is where I'm bringing it.
Both hands on here.
This one goes right here.
Do you see the hoo-hoos? Yes.
The Children's Natural History Museum in Fremont is a place to see.
It's a squid. Yeah, that's totally a squid.
And touch.
Pick one of these up.
Local history.
Pick one up.
We can see the things, the animals that lived here a million years ago, 100,000 years ago.
And this one goes right here.
Yeah, so they don't really have many dinosaur exhibits right now. There's a few dinosaur models and posters and toys and stuff like that, and there's a few little displays with dinosaur fossil replicas. But there's not, they certainly don't have a full-size Tyrannosaurus skull. A few weeks ago, I made some deliveries to the museum of some fossil replicas. Like this Edmontosaurus skull, full size. Baby Triceratops skull. And a few other little pieces. Camarasaurus skull, which we had in our office for years and years here. And then a nest of theropod dinosaur eggs, probably Oviraptorosaur eggs. But the plan now is to not just deliver things piecemeal, but start actually working on exhibits on, you know, like with the plinth and all. Like a big display base, maybe a plexiglass cover over the top, maybe. And then informational placards that I will design and print explaining what these things are. We can help tie them into some of the curriculum at the museum. All that good stuff. So with the Tyrannosaurus skull, for instance, the plan is to have that full-size skull and also have, well, kind of a display about Tyrannosaurus ontogeny. So I've got this right here. This is the Cleveland skull, which most dinosaur workers would say this is a juvenile Tyrannosaurus skull. So we can put this next to the full-grown Tyrannosaurus skull and talk about Tyrannosaur growth and development, Tyrannosaur ontogeny. You know, because this is one of those, really important topics in dinosaur paleobiology. Is growth and development of these animals over time, how much they change as they grow and develop. So again, not just have cool things for kids to look at, but have things that can teach important concepts about dinosaurs as living animals. We're actually trying to teach about paleobiology here. That's the idea. So yeah. Does that make sense? Yeah. Roughly the size of a modern horse is visibly upset. Oh, this one right here, the Cleveland skull. Yeah, little bit bigger than a horse skull, probably. Yeah. This may or may not be a juvenile T-Rex. That's actually a little bit controversial, and there should be a new paper coming out about that relatively soon. But yeah. Yeah. And taking that skull, making mold of it would be very powerful. Painting it is a very cumbersome way of making it, but once you have the shape... Oh, printing it. And Nuts from Carlin, I don't know if I actually have the rights to be able to mold and cast it. There might be some legal issues associated with that I won't get into right now, but yeah. Yeah. And Train 13 says, what did dinosaurs do with those small hands? Well, for a lot of these guys, like tyrannosaurs, they may not have done much with them. Those arms may have been vestigial, especially when these animals are full grown and you've just got this enormous, super heavy head. That's the business end of the animal. That's what's doing the killing and the eating and the everything else. The arms are maybe pretty close to useless, especially at full adult size. And that's the reason why they've got such small arms is, we talked about this yesterday, but you're balancing on two legs. It's like a teeter-totter. And so if you're going to have a huge, heavy, deadly head, that's your whole raison d'etre. That's what you do the killing and the eating with, the seeing and the thinking and the sniffing and the everything else. If that's going to be super big and heavy and that's your key to success, you've got to reduce the weight at the front of your body some other way. And reducing the size of your forelimbs through evolution, making your arms smaller and smaller, is one way to allow yourself to have such a big, heavy head. That's the key to your success. That does seem to be the case with tyrannosaurs. That does seem to be how this works.
Ontogeny.
So, yeah. Does that make sense? Yeah. Anywho. Yeah. And Notes from Cartland says, I would press for open source scans. So in this case, this scan isn't even available anymore. And the skull itself is also very much not available. I think it's being held in a private collection somewhere. But, yeah, this skull was sold at auction for over $6 million from Sotheby's. It is as far as I know, disappeared into a private collection. Nobody knows its current whereabouts, and somehow scans of it became available online. I scooped them up while they were there, and I've been able to print this, and now we can put it into a museum for the public to enjoy and for kids to be able to learn from and be inspired by and everything else. But, yeah, according to the auction page... Oh, come on. I see something about full rights. The skull is offered with full rights, which I think means that... Well, I don't know what that means, full rights. But that might mean that, that it's more or less copyrighted? I don't know. But I managed to grab a copy of it and print it. And, it's going to be in a public museum for everybody to enjoy. I'm going to be donating it, and yeah. So yeah, I'm really glad I was able to scoop that up. I think it might have been Dinosaur Dave who made that possible. I think maybe he sent me a link as soon as it popped up, and it was available for, I think, for a couple weeks before it disappeared again. So shout out to Dinosaur Dave there. Thank you, Dinosaur Dave. Yeah. Gowrax says, I might go see it once you get it up there and set up. Yeah, it'll be a few months, I think. But yeah. Anyway. Are you going to paint it? Absolutely, Chicken Bacon Swiss. I'll be filling in all of the seams and everything. Smoothing all of the 3D print lines and all that. And then painting it. The plan is to make it look even better than the original. The original, you know, the one that was auctioned off. Who knows how much of this is actually real? Like, there are, just looking at this, there's so many things that are wrong with it. Like the, you know, this projection off of the maxilla right here, this should occlude with the nasal bones here, and it doesn't. The nasal bones often seem, they also seem way too wide, like they've been sculpted or something. There's an awful lot that's wrong with this skull. And with any commercial specimen, you don't really know how much of it is real and how much has been sculpted, restored, just completely made up sometimes. So we can compare this to other T-Rex skulls, and it doesn't match up with a lot of other T-Rex skulls. Like, this one looks really weird and wonky. And so I'm going to be making some modifications to it because I don't trust the source material, basically. It was a commercial specimen. Commercial specimens they're not supposed to be authentic or to be real. They're supposed to look big and scary so that people with more money than sense pay too much money for them. So I will be modifying this significantly so that it's good enough to be in the museum. But yeah, like the teeth, for instance, are completely wrong. The teeth are way too narrow. They almost look like, I don't know, like saber-toothed cat teeth or something. They're almost blade-like. Tyrannosaur teeth don't look like that. The teeth of Tyrannosaurus in particular are really thick. Let me show you. Here.
If the situation called for still more protection, he simply grew.
Landorex, thank you for the follow.
From his body armor.
Welcome. It's good to have you here. Here's a cast of one of B-Rex's teeth. B-Rex is a nickname for a particular Tyrannosaurus Rex specimen. It's, I think, the stratigraphically oldest T-Rex in the world. But look at that in cross-section. It's super thick, super round. Tyrannosaurus had really, really chunky, thick teeth like this. Not made for slicing, but these are teeth that are specially adapted, evolved for puncturing and kind of for crushing. for crushing muscle tissue, crushing flesh, crushing bone, potentially. There are these carinae on there with serrations, so this is like the cutting surface of the tooth. But, yeah, but just look at how thick the tooth is. It's like a railroad spike or a banana almost. It's kind of a cliche, but Tyrannosaurus teeth have been described as lethal bananas. Because it is like a banana in cross-section. It's thick like a banana. This is the part of the tooth that would actually stick up out of the jawline. Everything underneath here is the tooth root. Right there. So you can kind of see that line where it goes from smooth and enamel covered to kind of this scrungier texture. That's the part that's actually in the jaw. Like embedded in the jawbone, and that's the part that would stick out. Yeah. So yeah. Pretty cool, right? So I'm gonna be probably altering some of the teeth so that they look more like this. I might even end up sculpting some of my own teeth that are more authentic than the ones in there already. I might end up cutting those out and sticking on more authentic Tyrannosaurus teeth. We'll see. But yeah, this one that sold for multiple millions of dollars, it's kind of garbage. Like, the teeth are not correct. So whoever bought this got ripped off. So somebody spent $6 million for a papier-mâché rebuild around a handful of parts. That does make me oddly happy, says Gojira. That's what often happens here. So here, Denver Fowler talked about this in this article. Wyoming dinosaurs sold for $15 million in Europe, but how legitimate are they? Yeah. Anywho. Vague descriptions of dinosaur specimens at auctions frustrate paleontologists like Denver Fowler. He sees it as a deliberate obfuscation to prevent potential buyers from knowing what they're bidding on. They might say a specimen is 90% real bone, Fowler said. What they mean is that 90% of the bones by number are real. If there are 50 ribs in the body with 200 bones, that's 25%. That's just ribs. And I know, you know, as a wise man once said,
gotta have them ribs.
But still, the ribs are not the most important part of the specimen.
Gotta have them ribs.
But yeah, if there are 50 ribs in the body with 200 bones, that's 25% that's just ribs. Sometimes they'll say something like 90% real bone by weight, which usually means that they've got big, heavy bones that make up most of the weight, like the femur. These are weird ways of describing these things. And Mandalorian Animal Lover, thank you for the follow. Amanda Lorian. Appreciate the follow. Welcome to Paleontologizing. Yeah. Casey Snowart says, you have a sound just for that? What, you mean this?
Gotta have them ribs.
Oh, yeah. If you know, you know. Anyway. Fowler noted that the term bone elements is highly misleading. A bone element could be anything from a complete 9-foot leg bone to an inch-long fragment that isn't identifiable as anything other than a piece of bone, yeah. And this has happened in some of these commercial specimens, too, where there'll be like a random chunk of unidentifiable dinosaur bone, and then the commercial people will take that, and they'll stick it in the middle of, say for the sake of argument, a femur that's entirely plaster, except for that one little chunk of random bone that they stick in there, and they go, oh look, now you have a femur with real bone. A femur with real bone. Like, it's really shady. It's really shady, the things that people get up to about this. Yeah. So anyway. Fowler says he regularly makes and updates skeletal diagrams for the specimens at his museum and notes how they're conspicuously absent from the dinosaur auctions he's seen. Takes all of 15 minutes to put one together, he said. Auctions don't do that. Yeah. So anyway, where was that up here? Yeah. They have these clowns wearing fancy suits and white Mickey Mouse gloves, holding on to these precious fossils, when you know that what they're holding on to is a big lump of plaster. Ever so delicately cradling a thing which isn't even real, he said. Billionaires might be the only people who are really getting screwed here, and maybe no one cares, he said. I don't like to see anybody getting ripped off, but I think we should all have a sense of decency and honesty. Do the auction houses have these scruples? Because I question if their buyers know that what they're selling is lumps of plaster and plastic that they're calling a dinosaur. I don't know how much of the Maximus specimen is plaster and plastic. I have what seem to be scans of the real specimen. And there are big parts of it that seem highly suspect. I don't know. So I'm going to be heavily modifying this to make it worthy of the Children's Natural History Museum of Fremont. But the anonymous buyer and seller... I don't know. It's probably a good thing that they're remaining anonymous because there's some shady stuff going on there, you know? Yeah. Isolated says, honestly, I hope all the fossils sold at auctions are mostly fake. Less of a loss to the scientific community and losing important fossils. That's often the case. Yeah, I really do suspect that a lot of these things are mostly artificial. Yeah. Anyhow. Yeah. With that said, shoot, let's get back to what we were talking about here with tyrannosaurs. There's a tyrannosaur there. Let's get back to dinosaur reproduction for Valendinos here. So here we go.
Dinosaurs might have done.
I'm gonna go run to the bathroom. I'll be right back.
Physical
I didn't get to go earlier.
And that's where those fossils published in 2016 come in. A team of paleontologists was working in Colorado looking for dinosaur trackways in a geological formation that preserves a lot of trace fossils. These are things like footprints and other marks left behind by extinct animals. Now, trace fossils might not seem as exciting as a dinosaur skeleton, but they give us a window into the past because they record an organism's behavior. Now, we have found hints about mating behavior in the bones of some dinosaurs, like tyrannosaurs with bite marks on their faces, because those could be signs of fighting over mates. But they easily could have come from something else, too. But that site in Colorado was crisscrossed by dinosaur trackways, and there the team noticed some odd scrape marks on the ground. First one set, and then another, and then another. All told, they would find around 60 scrapes there. And it turns out this wasn't the only site like this. They'd also discovered 2 more close by in western Colorado and 1 in the eastern part of the state. And these scrapes were a whole new kind of trace fossil, one that had not been recognized before. They had a distinctive shape with a deep groove down the center, as if the maker had sharp claws on their toes. And associated with some of those scrapes were footprints with 3 toes. So this convinced the paleontologists that the tracks were made by theropods. But then they had to figure out why big, probably meat-eating dinosaurs would have been digging in the dirt. And they proposed 4 hypotheses. First, maybe the scrapes were nests or part of nest colonies. Now, we have found dinosaur nest colonies before, and we know what bird nest colonies look like. The nests tend to be a standard shape with regular spacing between them. Nests also tend to have eggshells in or around them, and sometimes the remains of unlucky hatchlings too. But the scrape sites don't have any of these things, so the researchers think they weren't nests. So okay, hypothesis number 2. Maybe the dinosaurs were digging burrows
Very
or
funny,
looking for
DM
food or
Wang.
water. But digging doesn't seem to have been a common behavior for most dinosaurs. And the little evidence...
And this is why we got off on that tangent in the first place, is digging is probably a more common behavior in dinosaurs than we realize, and I'm really excited for some upcoming publications about that. Turns out more dinosaurs than you would expect would have dug burrows, including Leptoceratops. Oh man.
We have suggest that dino burrows would have been small, certainly smaller than these big dinos could have used. And since we think the scrape makers were theropods, they probably weren't digging for plant food like roots. There aren't any burrows belonging to things like small mammals there either, so it doesn't look like they were digging for prey, and the environment was wet enough that they wouldn't have needed to dig for water. Okay, hypothesis the third. Could the scrapes have been made to mark territory? Well, this isn't a behavior that we see in birds or reptiles today either. It's more common in mammals that mark those scrapes with the scent of their urine. So we're left with the fourth hypothesis. The scrapes were marks made by mating behavior. Now we know living birds are dinosaurs, and they're even technically theropods, which means we could use bird mating data.
Not technically theropods. They very much are 100% theropod dinosaurs.
As a model for what might have been going on. A lot of ground nesting birds, from shorebirds to the nocturnal parrot from New Zealand known as the kakapo, do what are called nest scrape displays. As part of their courtship behavior, males scrape the ground with their feet and move around in a certain area over and over again. Sometimes they do this to show off to females in hopes of being chosen as a mate. And sometimes they do it to warn rival males away. And sometimes the females get in on the action too as part of the courtship dance. This leaves behind traces a lot like those at the Colorado site, just on a much smaller scale. The dinosaur scrape sites were about 2 meters long on average, much larger than any living bird could make. And the paleontologists argue that the fact that so many different birds make these scrapes today is pretty compelling evidence that this behavior has a deep evolutionary history. In which case,
so that's the idea, is that when you look at the bird family tree, birds from very disparate branches from opposite sides of the bird family tree, they exhibit these behaviors. So that implies that it goes pretty far down the tree, maybe even beyond the origin of birds itself, into non-avian theropod dinosaurs. Like here.
These scrapes could be some of the best evidence we have of the lead up to dinosaur mating. Literally, the courtship dances of big theropods, preserved in stone. And since that study was published, we've even found more scrapes like these in different sizes and in other countries. Paleontologists have described scrapes from sites in Canada and South Korea. And the South Korean scrapes are a lot smaller than the ones from Colorado. Though they also show a three-toed foot, suggesting this behavior might have been something common to theropods. So this fills in a missing piece of the puzzle of dinosaur reproduction. Before, all we really knew was the outcome, that dinosaurs built nests, laid eggs, and at least some of them cared for their young. Now we have a better sense of what happened to get to that point, a kind of before and after snapshot of dinosaur mating. But we still don't know what happened during the main event itself, although that too might be coming into slightly clearer focus. In early 2021, researchers published a description of a dinosaur cloaca, the all-purpose opening of...
So the cloaca is, well, we can all be mature about this. But, here we go. The cloaca is the, like he said, kind of all-purpose orifice in dinosaurs, in other archosaurs like crocodilians, and in birds. There's a link to that article right there. I think marsupials might also have, maybe Carnotaurus, yeah, I'm not sure. Here. The cloaca is Latin for sewer. It's the rear orifice that serves as the opening for the digestive system, the reproductive system, and the urinary system of many vertebrate animals. All amphibians, reptiles, birds, cartilaginous fish, and a few mammals, like monotremes, asphoricids, so these are some of the insectivores, like hedgehogs, and marsupial moles. So I think it might be only marsupial moles and not the rest of marsupials. But monotremes have it. Echidnas and platypus. Yeah. Yeah. Interesting thing. This is probably going to be news to some folks, but yeah, the cloaca. It's, yeah. Yeah. And is there a reason we don't call it a vent instead, like we do with chickens? The vent and the cloaca are the same thing, Casey Snowart. Yeah. Yeah. Cloaca or vent. Yeah. Same thing. So we have that for a dinosaur now. Supposedly, if the specimen is legit. This was a commercial specimen here, and it was smuggled out of China illegally. So it does make me a little bit suspicious. Like, I don't know, it probably is legit, but anytime there is a fossil specimen that's of questionable provenance, like if there's if you're breaking the law in order to be able to get to that fossil, in order to be able to study it, it makes me less enthusiastic about accepting the conclusions of whatever study results. Is that fair? Yeah.
Dinosaur mating. But we still don't know what happened during the main event itself, although that too might be coming into slightly clearer focus. In early 2021, researchers published a description of a dinosaur cloaca, the all-purpose opening at the ends of the digestive and reproductive tracts shared by birds and reptiles. Their description was based on a specimen whose skin had been preserved as a film around its body.
So yeah, that specimen was, as far as I know, stolen from China, smuggled out of the country illegally, sold on the private market, and purchased by a European museum. Or, I don't know, purchased by somebody in Europe, and then it made its way into a museum collection. So I don't know the exact details. And again, I will say all of this is alleged in Minecraft, in a Roblox fan video, whatever, non-actionable, allegedly. But, yeah.
This exceptional preservation allowed them to reconstruct details of the dinosaur's soft tissue, including the anatomy of its cloaca. They compared it to the same structure in egg-laying mammals, amphibians,
That would be breaking
reptiles, and
Minecraft's
birds.
terms of service.
And while
that
it
you
had some
assigned.
similarities in shape to the cloacae of crocodilians, it also might have shared a certain lobe in common with birds. So this might be physical evidence that dinosaurs probably mated the way crocodilians and birds do, by putting their cloacae together with the male transferring his sperm into the female that way. Unfortunately, the details of how that happens has a lot to do with soft tissue structures inside the cloaca which weren't preserved. But they did find two intriguing things that might have played key roles in dinosaur mating. First, the dinocloaca seemed to have a set of bumps on either side that could be musk glands, which crocodilians have. Crocs of both sexes release stinky secretions from these during social displays. And second, the scales on the exterior of the cloaca were pigmented, leaving behind visible residue on the skin film itself. This suggests it might have been a visual signal, like it sometimes is in living birds.
Or in cats, where they stand in front of the camera and then they lift up their tail and their butt looks like a little Rolo. I like cats a lot. That's not one of my favorite things about cats. Definitely not.
Exterior of the cloaca were pigmented, leaving behind visible residue on the skin film itself. This suggests it might have been a visual signal, like it sometimes is in living birds. So where does that leave us on the evidence for dinosaur mating? Well, it looks like we're closer to understanding dinosaurs as animals that did all the normal stuff that living animals do. And that, as is so often the case, what they were doing was something between what birds and crocs do today. Or, I guess, birds and bees.
No, birds and crocs. Yeah. Lovely video from PBS Eons. I'll give you a link right there. I'm really impressed with the breadth of the topics that PBS Eons covers. It's good stuff. Yeah. With that, let's take a trip back in time, not to the Mesozoic, but to the late 1990s or early 2000s. early 1990s rather, or mid 1990s. 1994 is, I guess, when this episode aired. And let's all be mature about this, shall we? In the spirit of Valentine's Day, let's all be mature adults here and not snicker too much at this. If you've got a really, really funny joke, make sure that it's appropriate to put into the chat before you type in it. We might have kiddos watching, and I like to think that one of the big appeals of this channel, the science outreach that we do here, is that it is appropriate for all ages. So show a little bit of restraint if you can. I'd really appreciate that. I don't want the mods to have to be deleting messages left and right. So, if you're unsure if it's appropriate, keep it yourself. Thank you, Charlie's Dragon. Wise words. Take that to heart, everybody. Yeah. Anywho, yeah, this is gonna be a little goofy. Let's get into it. From 1994. That's what, like 5 years ago now at this point? It's a long time ago. Let's watch.
On those hot Jurassic nights, how did the dinosaurs make the Earth move?
Oh boy.
For millions of years, their sex lives have remained a primordial puzzle. Now science is giving us a tantalizing look at how these creatures courted, mated, and cared for their young.
You know, it's part of life. Let's be mature about it.
It's time we had a frank talk about dinosaur sex.
About Dinosaur X. There you go. Yeah, I know, right, Charlie's Dragon? We can be more mature than the video can. Yeah. Stand for the anthem, yes. There you go, Salamander. It is a great song. Turn it down a little bit. The volume is a little bit too loud.
For 65 million years, the love lives of the dinosaurs have been a dark mystery.
Thank you, Gojira. Yeah.
Probably the least researched and most misunderstood part of dinosaur behavior is sex. Mere bones tell us little about acts of the flesh. At last, paleontologists such as Bob Baca are piecing together a complete picture of dinosaurs as creatures that pursued life with a passion.
And the cloaca is an exit, not an opening? No, it's actually both, Rainstorm Fur. It is all purpose. Urinary, digestive, and sexual orifice too.
We're looking at their horns. We're looking at their
Thank you,
hooters, the
Pick.
noisemakers in
Yeah.
their snouts. Dinosaurs were as invested in sex as a bighorn sheep or a moose, because without sex, you don't get your genes into the next generation. If you don't do that, you're a Darwinian zero.
To pass on your genes, you first have to attract a mate. And the dinosaurs developed an array of sexual lures. Bright colors, elaborate displays, and come-hither gestures.
You got to advertise. The dinosaur world evolved very fast. Fast-evolving animals advertise a lot. So there would be sonic advertisement, there would be visual advertisement, it would be in color, it'd be in dance, it'd be a full Broadway musical of courtship display.
He makes a good point, though, as usual, I guess.
Such behavior.
So, one of the themes when we're watching this is going to be that so many of the different aspects of dinosaur anatomy that people talk about, like, for instance, the plates of a stegosaur, one of the ideas is going to be, oh, maybe those were used for sexual display. Well, maybe, I guess. That's kind of an easy answer. some of you are probably familiar with the concept where, like, I guess in archaeology, an easy answer is, oh, well, this bizarre thing, we don't know what it is, must be religious purposes, you know? It had ceremonial import. Okay, that's easy to say. You hear that a lot for weird aspects of dinosaur anatomy, like the plates of a stegosaur, that are seemingly hard to explain. But the thing about animal anatomy that's used for sexual display, it's usually different between sexes. And that doesn't seem to be the case for things like stegosaur plates, or the frills of ceratopsians, or the horns of ceratopsids. There doesn't seem to be any evidence that males and females had differences there, at least not in terms of the osteology, the bones. Maybe they were different colors, like you see with, you know, male and female birds having different colors in their plumage. But colors don't readily fossilize most of the time. So the idea that, like, the plates of a stegosaur evolved for sexual display, we don't really have a good reason to think that that's true. It might be some other form of social display like that. But showing off to mates, there's nothing about the anatomy of the plates that implies that it would be for mating display, you know? So yeah. Yeah. Anywho. Yeah. And halation effects as stegosaurus plates look like big old heat exchangers to me. That is one idea, halation effect. Yeah. One idea is that the plates of Stegosaurus almost acted like the fins of a radiator. And I'm trying to find you a good image of that, and there's just... Google Images has got nothing. That's frustrating. Shoot. There was a lovely picture of this in the Tiny Perfect Dinosaur book. I don't know if I'm going to be able to find that. Yeah, shoot. Oh well. There's an idea that the plates on Stegosaurus were used for cooling its blood down, that it could flush blood up into those plates because there are grooves on the surface of the plates. That maybe it could send blood up onto those plates and then a nice cool breeze would flow through, cool off that blood, and the blood could be circulated through the rest of the body. Almost like the fins on a radiator. You know, that's how radiators work. As your vehicle puts fluid through these, and then the high surface area allows the heat to dissipate, and then that now cooler fluid can flow throughout the rest of the system. The problem with this idea is that the blood vessels on Stegosaurus, they go up and they terminate. They don't go in a loop like they do on a radiator. So here's a Stegosaurus plate at Museum of the Rockies. Right there. So you'll see the blood vessels go up, and then they stop. There's no nice loop that they go through, like in a radiator. I've always been really skeptical of this idea that the Stegosaur plates evolved for thermoregulation. Because I feel like there's so many easier ways to do that than to develop these big, expensive, bony protuberances like this. To me, the idea of display makes so much more sense. If the whole point is to create this big, expensive thing, almost like the feathers on a peacock or something, then that makes a lot more sense. This, to me, the pattern looks much more like the pattern of blood vessel grooves that you see on, like, the beak of a toucan or something like that. You know, like it evolved to be brightly colored as a display thing. So we see this in a number of organisms today. Not just toucans, but other birds and critters like that also. Yeah.
But Dilophosaurus's crests would have been far more durable for another reason. Believe it or not, it's not just extinct
There's a cassowary's casque
that have thin, air-filled, bony crests.
with those same kind of blood vessel
Dozens
grooves.
of species of dinosaurs with similar crests that are still alive today.
Yeah.
Many modern birds also have air-filled, bony crests connected to their sinuses.
So Stegosaurus's plates do not seem to be air-filled. We have no reason to think that they're hollow or anything like that. But they do have those same blood vessel grooves that we see in, you know, that feed nutrients to keratin in, say, modern birds.
And all of them sheathe their crests in keratin, the same hard, horny material that makes up birds' beaks. Keratin is a remarkably durable material, so much so that large cassowaries can safely run through dense jungles at full speed.
So they almost use that casque like a crash helmet, or at least that's what you read about in encyclopedias about casque. Like, I don't know if it's ever actually been observed that they will use that casque like a crash helmet, but I don't know. It's certainly been written many times.
Large hornbill species actually fight with their hollow crests, and some parts of these hornbill crests barely have any bone supporting them at all.
So again, these are hollow, and these do seem to have a role in in generating sounds, almost like a resonating chamber. In some of these birds, it also seems to be involved with thermoregulation, but that's because they're hollow. Stegosaur plates are not hollow. And so I would think that if they were involved in thermoregulation, hollowness would be like a key aspect there, but they're not hollow.
Keratinous covering also significantly enlarges the size of the crest in life. In some birds, the keratin expands the size of the crest up to 1.5 times the size of the underlying bony crest.
Yeah.
Keratin can also be grown in any color. Thus, these showy crests play an important role in species recognition and sexual display, helping birds to communicate and attract mates. But they have other functions as well. One recent study demonstrated that cassowary crests are an important structure for thermal regulation. By flushing the air-filled crest with blood, cassowaries can offload excess heat, which helps to keep their brains cool in the hot tropical climate where they live.
So I don't know. I would like to read that paper, and then maybe that's an upcoming project that I could, maybe I could run with that idea. That idea of thermoregulation in stegosaur plates. What would we expect to see if that actually was used for thermoregulation? Because I don't think what we see in stegosaur plates works well with the whole thermoregulatory hypothesis. But yeah. Anywho, yeah. Bojil says, what about an attack from above? And that was the original idea behind stegosaur plates. Here. Like that book there. The name Stegosaurus means roof lizard. Because when people like Othniel Charles Marsh, who named Stegosaurus, were originally studying these animals, There was a hypothesis that maybe those plates served as armor to protect it. And this is the group that we call Thyreophorans. These are armored dinosaurs, but it doesn't seem like the plates really evolved as armor. Roof lizard. When Marsh first described these critters, this is what he thought the plates would have looked like. He thought they were like tiles on a roof, where they actually would have protected the animal from above. But it turns out they didn't lie flat like that. We know that the plates stood up straight like that. So the entire flank of the animal, these are fairly round animals, would have been unprotected. So not good as armor. Also, the dinosaurs who would be attacking these guys, like Allosaurus, they're not that tall. They're not going to be attacking from above. They're going to be attacking from the side, which is unprotected by those plates. So yeah. Glad the dinosaur didn't have shingles. Yeah, it does look a little ridiculous when you look at it that way, huh? Yeah. And could they move the plates? That's a really good question, Train 13. Here. Bob Bacher, this guy who's going to come up again and again in this documentary here, he proposed back in the 80s that these guys could waggle their plates or move them. That's the thing about stegosaur plates, is that they do have like a big articular end to them. So there's like a big attachment point at the base of the plate that's embedded in the back of the animal, just kind of floating there in the flesh. So it's like a big thick base that's got a lot of rugosity on it, and then the plate gets thin and goes straight up like that. He did propose back in the 80s in his popular book, The Dinosaur Heresies, that maybe they could waggle their plates back and forth. And I think that's an idea that should be studied further. It's an intriguing idea, I think. I don't know. I suspect that dinosaurs like Stegosaurus would have been really flamboyant animals. Really, almost kind of obnoxious. They're walking around showing off their plates, you know, like a multi-ton peacock. You know, I almost picture a stegosaur walking into a meadow where there's some camptosaurs and some sauropods grazing, and they all look over and they roll their eyes. Like, oh boy. Here comes the stegosaur, and the stegosaur's like, hey everybody, look at me. Just obnoxiously showy. But yeah, this is a really lovely, I love this Stegosaurus model. It's so good. In fact, I almost kind of want to put this on the wish list because it's just gorgeous. It is a bit pricey, but oh man, is it gorgeous. I'm gonna go ahead and put it on that list. Because I don't have a Stegosaurus model that's that nice. It's really good. It's really good. But yeah. They're a Ford Escort with a fat pipe and a neon underfloor lighting. There you go, Gojira, yeah. And a crazy sound system. But in his book, The Dinosaur Heresies, Bacher does... I don't know, Bacher's always full of ideas, and he doesn't test them a lot. but he certainly does throw a lot of ideas out there. He's very much an idea-driven guy, I think. But, there we go. Stegosaur. How stegosaurs flapped their plates. Stegosaur ancestors had bony armor plates shaped like those of gators. The plate base was very wide and firmly embedded in the outer layer of tight skin. But during stegosaur evolution, the plate base became very narrow, and a sheet of skin muscle attached to the side of the plate to swing it from side to side. So, yeah. Stegosaurus may have been a grand performer under attack, Bakker writes. A 5-ton ballet dancer with an armor-plated tutu of flipping bony triangles and a swinging war club. Browsing peacefully on the tops of bushes, perched upon its hind legs and tail, its keen eye quickly catches the movement of 2 huge Allosaurus hunting Alper along the floodplain. The pair of Allosaurs stride quickly to the attack, one from either side. The Stegosaurus alights defensively on all fours. The first Allosaurus darts quickly for the Stegosaur's neck. Instantly, the intended victim pivots and lowers its armored triangles. The Stegosaur suffers a cut across its snout for its efforts. The second Allosaur lunges at the other flank. The Stegosaur's tail slashes out to meet the charge. With an audible whoosh, the 4-spiked tail barely misses the Allosaur. That's too much for the would-be predators. They back off from the Stegosaur tail, still capably brandishing its weapons, and off they go to find easier pickings. It's an interesting idea, but I wonder how you'd go about actually testing it, you know? Here's a dramatic illustration of a Stegosaur battling a Ceratosaur right there. Yeah. Looks like the Ceratosaur might end up with some 3-foot spikes through its groin. Yowza. Yeah, well... It's an interesting idea. The whole Stegosaur plate thing, and it'd be nice to come up with a good way to test that, because that'd be a project that I would love doing, you know? So yeah. Yeah. Anywho. Yeah. Let's continue here, shall we?
Next generation, if you don't do that, you're a Darwinian 0.
Dr. Irrefutable says, do you ever get tired of seeing Bakker in these old documentaries? I feel like he dominated the conversation for a couple decades. I mean, he certainly didn't publish very much, so it seems like most of the time he's just in the documentaries. Yeah. I don't know. As somebody working on dinosaurs, you don't see Bakker's name come up very often in the literature. He shows up in just about every one of these documentaries, but you don't see his name on scientific papers because he just didn't publish very much. I think the last paper that Bakker published might have been, what was it like? It was about 10 years ago. And before that, it may have been about 8 years prior. He doesn't publish very much. And yeah, the last paper that I remember seeing his name on was the Dakotaraptor description. Ugh. In 2015, I think? Maybe 2016? I've been told that Bakker kind of became very disillusioned with the whole publication process. He doesn't really, believe in publishing anymore. And maybe he's got his reasons, sure. But, I don't know. That is kind of cause for suspicion. It's like if you're not getting science published, can you really call yourself a scientist? You know? I'm not trying to be gatekeepy about this. Just like, I don't know. It sounds really unfair when I say it like that. So I feel the urge to backtrack a little bit, but you know what I mean. You know. Yeah. But yeah. And Chaotic Time Traveler says, Bakker did help maintain my interest in dinosaurs after I was told I couldn't be a paleontologist as a child. No, Bakker, I think Bakker does not get nearly enough credit for essentially the PR work that he did for dinosaurs in the 90s and the early 2000s. There are many, many people around the world whom Bakker helped get interested in paleontology. And that's a difficult thing to quantify. It's a difficult thing. It's not like publication numbers or something where you can just say, hey, look at how many papers, you know, this scientist published. Isn't she so accomplished? It's interesting when we're talking about stuff like this because we scientists tend to judge each other's work based on how often our work is cited and how many publications we have, that kind of thing. But appearing in documentaries, helping popularize the science, that's also really, really important. And there are many paleontologists who are working today who would not have had jobs were it not for people like Bob Bakker who helped to popularize the science. So that's something that's really important to consider, and it's not something that gets talked about enough, I think. So, yeah, a dinosaur hype man. I like that salamander, yeah. Does he still go to SVP? I haven't seen him since 2013, Casey Snowhart, but I haven't been to SVP that often either. So, yeah. Anyway, I'd say Bakker's been definitely a net positive for dinosaur science. I think that should be uncontroversial.
Here without you as an inspiration and a beacon of hope for SciComm.
Oh, science
Thank you for
dreams.
all you do, Professor Mendoza. Less than 3.
Thank you, Belen. You make me blush. My goodness. Appreciate you, Belen. I really do. Thanks for helping keep me here online. That financial support means a lot, and I'm grateful for it. Thank you for everything that you do for science communication on this platform, too. Science Streams. The first ever ambassador for science on Twitch. Official ambassador status. First ever Twitch ambassador whose raison d'etre is educational content. You're a pioneer, Belen. Thanks for doing what you do. Anywho, yeah. Crimson Carnotaurus makes a really, really good point. Good luck finding new talent or attracting money if no one gives a hoot with no public interest. Yes, and that's the way things were with dinosaurs for a long time. Throughout, like, the middle of the 20th century. Essentially, from the Great Depression in the US up until the 1970s, very few researchers actually gave a darn about dinosaurs. They were seen as kind of an evolutionary backwater. I feel like I'm borrowing some of Bakker's terms here. But yeah, it's like dinosaurs really weren't worth studying. Until Bakker's advisor, John Ostrom, discovered and described and helped popularize Deinonychus in the 1970s. Kind of triggering the dinosaur renaissance. And one of the hype men there, to get people interested, One of the people fanning those flames was Bobbert T. Bacher. So yeah. Sometimes it would be nice to see some other faces in documentaries like this to answer the question. Aside from Bacher appearing all the time. But Bacher's also very entertaining, and you can see why documentary producers really liked him. Our annual Theropods Giving tradition is, well, I mean, shoot. Here, check this out with,
directly to modern birds.
With Bacher back in the 90s.
If Bacher's right, Thanksgiving will never be the same.
Okay.
He's a showman.
I love to do this. I do this every Thanksgiving. You may think that this is a turkey. This is not a turkey. This is a dinosaur. This is a raptor. And I can prove it to you. The hand of the turkey, wonderful device. The hand of the turkey has a thumb and 2 fingers stuck together, index finger and middle finger, all attached together to make a swivel. Zink, 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 zink. No other animal alive today except birds have that kind of hand. Wiggle, 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 wiggle.
Charlie's Dragon, I think, makes a really good point here. Bacher seems to talk a lot about ideas that have very scant evidence, and I'm a bit skeptical of how he presents it as fact. But there's a lot of evidence, or it's self-explanatory. It's misrepresenting what dinosaurs are in a way. But he also has great clips like this. I know, right? So yeah, I don't know. As somebody who does science outreach full-time, I appreciate the showmanship. I appreciate the enthusiasm and the passion that he has. And, as a popularizer of dinosaur science, Bacher's the GOAT. I think he really is. But not everybody can be Bacher, It's important that there is a Bacher, but it's also really important that I think in some ways Bacher almost gives room for other dinosaur researchers to be a little bit more circumspect and a little bit less outlandish in their claims, He's kind of a crucial component of that ecosystem, especially in the 90s, Yeah.
Now, for your edification, here is a dinosaur hand, thumb, and 2 fingers stuck together, and a swivel joint at the top, so the whole thing goes back and forth, zink to zink to zink. That is a turkey hand. Turkey with a bad attitude, but that's a turkey hand.
Anywho, so yeah, the classic clip right there. That's kind of how I feel about Bacher's book, The Dinosaur Heresies, too. This is like Bacher's first and I think only big dinosaur book that he ever did. This is from 1986. And the through line in this is people's perception of dinosaurs, all wrong prior to this book. I mean, it says right here on the back cover. They're explicit about it. The subtext is text. Enter a brave new world of prehistoric wonders. For over a century, dinosaurs have been thought of as plodding, dim-witted giant lizards too awkward and ill-equipped to survive the ravages of environmental change. But now Robert T. Bacher offers startling new evidence destined to forever alter mankind's perception of the much maligned monsters, depicting the dinosaurs as never before imagined, hot-blooded, amazingly agile, and surprisingly intelligent. So that was already kind of underway in the 80s. But Bacher was able to kind of claim that mantle in a way that I think is really stuck in a lot of ways. This is an excellent book for getting people interested in dinosaurs. There's a zillion ideas that are presented in here. Many of them still remain untested to this very day. Like the stegosaur plates waggling hypothesis. that idea. Somebody should really look into that. Maybe I'll end up doing that, you know? I found this book tremendously inspiring when I was about 10 or 11 years old. This is my very favorite book at that time. Tremendous impact upon my life. I thought it was phenomenal. I remember getting a copy from my grandma and grandpa for Christmas one year, and it was like a revelation. Bakker's passion, his enthusiasm were absolutely infectious. And that's the kind of passion and enthusiasm that I try and carry forth when I'm doing live streams like this. Like, this is nowadays how I make my living. So in a way, I owe a lot to Bakker. There's a lot in here that also turned out, it didn't pan out. A lot of scientific ideas that have been tested, and they turned out not to be true. So, yeah. It's a mixed bag, but you gotta give Bakker credit, I think. Yeah. Anywho, and your passion for this is palpable. Thank you, Lenina. I'm glad. This is not an act or anything. This is how I feel. But yeah. Yeah. And I think that might be John Gertsch Kleber. I think it is. But yeah. Yeah. Anyhow, let's continue.
To pass on your genes, you first have to attract a mate. And the dinosaurs developed an array of sexual lures. Bright colors, elaborate displays, and come hither gestures.
You got to advertise. The dinosaur world evolved very fast. Fast-evolving animals advertise a lot. So there would be sonic advertisement, there would be visual advertisement, it would be in color, it'd be in dance, it'd be a full Broadway musical of courtship display.
Such behavior was overlooked by early paleontologists.
Here's a gallery of some of the great dino thinkers of this country. Professor.
Yeah, here, there's Marsh right there. We've got Barnum Brown, Henry Fairfield Osborn. Is that Gilmore right there? I can't really see.
Professor Marsh of Yale, he found Triceratops. Professor Osborn, he found T-Rex.
Barnum Brown found T-Rex.
Dr. Barnum Brown dug dinosaurs all over the world. S.W. Williston ran the department at Chicago. Now, these guys thought about attack, predators and prey. They thought about chewing, how a horse or a brontosaur would chew plants. They thought about locomotion. They thought about climbing mountains and digging holes, but they didn't think about sex. It was verboten nearly totally.
Early paleontologists barely scratched the surface of dinosaur behavior. To them, the extravagant array of dinosaur horns was used strictly for attack or defense.
These sex-free dino thinkers weren't letting dinosaurs be real, living, breathing animals. Here's a real, living, breathing animal. It's a bighorn sheep.
Well, it looks pretty dead to me, but point taken.
It's a complete animal. It eats plants, it runs away from predators, but it's also thinking about courtship, about sex. It's literally got sex on the brain. These horns, which dominate the skull architecture, are for ramming other bighorn sheep during courtship contests. And what the dino thinkers didn't let dinosaurs do is grow things for sex.
So here's the thing, though, is that, yeah, that is used for mating contests. Male bighorn sheep will, crack heads like that. The females have got much smaller horns. We've got strong dimorphism there. So with bighorn sheep, the males and the females look very different from one another. The males have got these huge horns that they use in these contests. Females don't have that. They've got horns, but the horns are much smaller on a female. It's pretty dramatic. I mean, look at that. We do not see this in dinosaurs. We don't. If we're talking about horned dinosaurs, as long as we've got multiple specimens, say we've got 100 specimens of the same horned dinosaur, we might see a lot of variation. You know, maybe different sizes of the horns, different orientations, stuff like that. But we can't split them up into male and female. Like, some have big and some have small, and it's 50-50. No, it's like, it's just a smooth gradation. And that's not true for other fossil organisms, like with other mammals that have sexual dimorphism. Other mammals other than bighorn sheep. We can see strong dimorphism, dimorph to form. We don't get that for dinosaurs. And so the idea that dinosaur horns and frills and stuff were used in mating displays just doesn't make a lot of sense. Because in animals that use their morphologies for that, you've got strong differences between males and females, and we don't have that for dinosaurs. We just don't. So I'm really skeptical of this idea.
Dinosaurs, like modern bighorn sheep, developed headgear for the same reasons, to intimidate rivals and impress a mate.
Yeah. So again, let's look at the bighorn sheep there. See if I can find you another video. Bighorn sheep headbutting. It's pretty wild. Kevin Costner. No, I'm pretty sure that's a bighorn sheep, Scorch Hellfire. There you go, big clicker. Yeah, so don't try and headbutt a bighorn sheep or you'll die. Yowza. Yeah. Here's another example.
It's rutting season, and males are competing for the right to mate. Rank is constantly reinforced and often contested.
Oh.
Their ultimate weapons are their curled horns that can weigh up to 30 pounds. They are literal battering rams.
And there's a female. See, she's got smaller horns than there's babies.
2-week-old ram lambs will begin to butt heads in mock battles. In the early development of a social order they will be part of for the rest of their lives. Most of the year, these rams live in bachelor groups that adhere to a rigid hierarchy largely determined by age and size. Their life has a singular focus, and this is what they've been preparing for all year long. A male can determine if a female is ready to mate simply by smelling her urine.
Simply by? That seems like an involved process.
By tilting his head back, so her pheromones can reach a sense organ in the roof of his mouth.
This is the Fleming response. So the cats that I live with do this too, where like Minnie Pie will walk up to Sweetie Pie and she'll kind of like stick her nose next to Sweetie Pie's butt, and then you'll see her go like that. She's doing the Fleming response. So this is something that a lot of mammals do that. Where they're kind of like curling back their lip so that pheromones can get up into, what is it, the Jacobson's organ or something like that? Yeah.
Females are an estrus for just 48 hours. And during this time, the rule book rams have lived by is thrown out the window. A higher-ranking male is guarding this female. But he's up against a reckless youngster, willing to risk it all.
We don't really have evidence that Pachycephalosaurs did this chicken bacon Swiss. It's an idea that's been thrown around a lot. But, yeah. It doesn't seem like their domed heads are actually well adapted for this kind of ramming.
The lower-ranking male knows he can't win in a head-to-head fight. So his goal is to separate the female from the higher-ranking male. Just long enough to mate.
All right, okay. Anyway.
Mighty T-Rex, it seems, also had sex on the brain. Bony ridges on top of the skull were well suited for battling rivals head-to-head over a potential mate.
If you have great genes, if you're a Tyrannosaurus Rex and your genes are the best possible for running and killing prey, it's still no use at all if you can't get those genes out there and mix them with the genes of another T-Rex of the opposite sex and make little Rexlets in the next generation. T-Rex has sort of a bony football helmet behind the eye as a cushion for the eye and the brain. Along the snout, these raised, roughened edges that in life would be covered with very tough skin. Of course that's for whacking.
To imagine two T-Rexes whacking heads with each other in sexual combat, just watch these woolly bison go at it.
Muskox.
Now picture the same scene replayed with creatures who weighed up to 8 tons.
Yeah, I don't really think they were doing that. I think those lacrimal horns and the big bony post-orbital bosses and stuff like that on Tyrannosaurs, they are impressive, definitely. Here, to go back to our Tyrannosaurus 3D print here. Let's pull up that file so I can show you, since I don't have it fully assembled yet. But there we go. So this is the cranium. There's the skull of this animal. There's the eye socket, the orbit right here. And then above that, you've got this big protuberance on the post-orbital bone. And then to a certain extent, you've got this big kind of gnarly bit on the lacrimal, too. And so what's being proposed in that documentary is that, oh, well, they butted heads using this. doesn't make a great deal of sense, I don't think. Head-to-head combat with tyrannosaurs. At least they're not lining up 100 meters apart and running at each other full tilt like that. I don't think that's what these guys are doing. But I think that was probably more for display, but maybe there was some flank butting or something. You know, if these guys are just getting really rowdy and they're competing for mates, I could see that kind of thing. You know?
The Pachycephalosaurus, too, seemed to have a head for sex. It towered 10 feet above the ground and likely used its enormous 10-inch thick brain case to batter sexual rivals.
I don't think that's true either.
The dome
this whole idea
would identify it to the opposite sex as a strong mate.
And so that's the thing, is that it seems like males and females, we've got no evidence that they had different shaped heads. Both the males and the females would have had this, unlike we see in bighorn sheep or in any other kind of you know, animal that engages in that kind of combat over mates. If they're doing that, that means that the males and the females look different. The males have got a big, you know, head or horns or whatever in order to do this, and the females don't. We don't see that in dinosaurs. We don't have any reason to think that there's strong sexual dimorphism there. J. Marianne, thank you for the raid. Welcome to Paleontologizing. It's good to have you here, and happy VALENDINOS to you. Welcome, welcome, everybody. How was your stream, J. Marianne? I hope it was excellent. Welcome, one and all. Look at that dinosaur percussion there.
J. Marianne is bringing the beat along with their 193 raiders.
Thank you, J. Marianne, for the raid. Welcome to Paleontologizing. Welcome, everybody. My name is Danny Anduza. I don't normally dress like this,
You might say.
but it's VALENDINOS today.
Completely covered with thin, bony plates.
My name is Danny Anduza. I'm a dinosaur paleontologist. I work on dinosaurs. I study dinosaurs. I publish on dinosaurs in the scientific literature, and I dig up dinosaurs during the summer. But we're talking about dinosaur courtship behavior. We're talking about dinosaur reproductive behavior today. And we're taking a look at an old documentary from the 90s about this, and we're talking about what's changed, how our current perception of these concepts is very different today. The new fossil evidence that's caused us to kind of reconsider some of these old ideas, all that good stuff. The Real Woke Bay, High Quell, Punk Avenger, Ghosty Smith, Tofu Ghost, Adric Backup, and Erux, thank you all for the follows. Welcome, welcome. It's wonderful to have you here. Hello, hello. Yeah, it's not yet digging season, or so yet. Yes.
The answer.
Erux, yes indeed. It'll be June when I'm back out in Wyoming digging up dinosaurs. Looks like. Yeah. And yeah, I don't normally wear this. It's, you know, it's VALENDINOS today. I thought I'd do something special, so hence the smoking jacket. Again, I don't normally dress like this on stream. Annie Fraser says, is a Komodo dragon a dinosaur? It's not. I'm really glad you asked. Here, and again, I love this because Q&A is the bread and butter of what we do here on Paleontologizing. If you want to know what is a dinosaur and what isn't, this is a really handy chart for the way that we as scientists classify living things is not based on what they look like. It's not based on their vibes. Those things can be clues as to who's related to who. But when we're classifying living things, it's actually based on real relationships, evolutionary relationships. So on this chart, dinosaurs begin right here. There is one characteristic that you need to be a dinosaur. One thing that marks you as a dinosaur, and it's having evolved from an earlier dinosaur. Dinosaurs form what we call a clade, so they're a group of living things that all share a common ancestor. So it's like a true evolutionary group, a true biological group of organisms. All clades, all true biological groups come from a single ancestor species, And then everything that evolved from that species is a member of that group. Dinosaurs are like this. That's why birds, like that duck you saw in the raid message, birds are dinosaurs. Because we can trace their ancestry back to the first dinosaur. Birds evolved from earlier dinosaurs who had feathers. Dinosaurs not too different from like Velociraptor, who also had feathers. That's where birds came from. So birds are dinosaurs because you can trace their ancestry back to earlier dinosaurs and back to that first dinosaur. Crocodiles or turtles or Komodo dragons, they are not dinosaurs because they didn't evolve from that first dinosaur ancestor. They are distantly related to dinosaurs. They are reptiles after all, like dinosaurs are, but you got to go further back to where they share a common ancestor with dinosaurs. So you got to go further back to before the first dinosaurs.
Always missing bones, missing.
Does that make sense? Yeah. So anyway, yeah. It's great to have everybody here. Thank you again, Jay Marianne. Did I miss your message earlier? Did you talk about how your stream was? Because I'd love to hear about it. Anyhow. It's an honor to get a raid from you, Jay Marianne. Thank you, thank you. You've got some good people, and I appreciate you. Thanks for being a comrade. We've got a bunch of cool new people here. I think it might be a great opportunity for a quick little welcome video to introduce some of the new folks to the channel. Give me a 1 in the chat if you'd like to see a welcome video. Kind of introduce me, introduce why in the world a paleontologist is here on Twitch in the first place. What's this channel all about? All that good stuff. Give me a 1 in the chat if you'd like to see that. And without further ado, we will call forth...
The moon does exist.
Thank you, Dart.
Dinosaurs always ate their vegetables.
Video Game Royal, I appreciate you. Jermathy, Soup, Janny, thank you all. Previously recorded Danny is sneaking up behind me right now. We'll turn things over to him for a few brief minutes here. Previously recorded Danny, why don't you introduce all these cool new folks to the channel?
Thanks, present day Danny. You know, people ask me all the time, Danny, how did you first get interested in paleontology? And I've always been interested in fossils from the earliest time I can remember, particularly dinosaurs. My parents like to say that I decided I wanted to become a paleontologist pretty much the moment I realized I couldn't grow up to be a dinosaur. And believe me, I tried.
I was born and raised in the San Francisco Bay Area, which is a lovely place to grow up. Except that we haven't got any dinosaur fossils here. So right after high school, I packed up and moved to Montana, one of the best places in the world to find dinosaurs. Just a couple days after I arrived in Montana, I started working at the lab at Museum of the Rockies, and the paleontology program founded by Jack Horner. Jack's done a lot of amazing things in his career, but you may know him as the scientific advisor on the movie Jurassic Park.
You consulted on that movie.
I did consult on all those movies.
And they said the guy, Alan Grant, was you.
Yes. Yeah, well, fortunately, he didn't get eaten.
But we wanted a credible resource that could back up several theories that we were sort of expounding. And one was that dinosaurs eventually evolved into birds.
And even the word raptor means bird of prey.
And that's something that Jack Horner believes in and could defend if necessary, and Jack Horner became our credibility.
It was in this program that Jack built that I learned how to be a dinosaur paleontologist, and how to think outside the box. I've done work at a number of other museums around the American West, helping to prep fossils, design exhibits, and educate visitors. I did a fair bit of eclectic fieldwork in various places, identifying and collecting early Cretaceous dinosaur tracks on the Idaho border, Sphenodontian fossils in the gravelly range of the Rocky Mountains, Cenozoic fishes in western Nevada, but most of my work out in the field was with Dr. Denver Fowler, who is now curator of the Badlands Dinosaur Museum.
In all, I've worked probably a few hundred sites throughout the late Cretaceous of Montana, and the Hell Creek and Judith River formations, digging up dinosaurs. Lots and lots and lots of dinosaurs. And from time to time, that work has even garnered some media attention.
Montana's news leader.
5 paleontologists are excavating what looks to likely be a new species of armored dinosaur.
We found its head, and we found parts of its armor and plates, and so it should be a new species.
And much like my fieldwork, my research focuses on dinosaurs. I'm particularly interested in their behavioral functional morphology. All these bizarre anatomical features that certain dinosaurs had, I want to know what they used them for. Right now, I'm working on a study on spinosaurs. Alright, but don't ask me too much about that because it's still a project in the works and I can't give away too much just yet till it's published. But anyway, a couple years ago I realized that things were definitely headed downhill in Montana. So I packed up and headed back to the West Coast. And I've become kind of fed up with all the bullshit in academia, so I found myself another job. I am now a teacher in early childhood education. And let me tell you, it's been a natural fit since day one. Now, given that I get to design the curriculum, my students now know more about biology, classification, and the history of life on Earth than most adults do. I've been helping raise a new generation of young scientists. Then, coronavirus hit. In mid-March, when all the schools shut down in San Francisco, I started holding classes over Zoom, and we picked up right where we left off. 1, 2, 3. I love digging in the dirt with just a pick and brush. Finding fossils is my aim, and so I'm never in a rush because the treasures that I see are rare and ancient things like velociraptors' jumps or Archaeopteryx's wings, and all the kids who wanna see them lining up at our museum. I am a paleontologist. That's who I am, that's who I am, that's who I am. I am a paleontologist. That's who I am, that's who I am, that's who I am. That's who I am, that's who I am, that's who I am. That's who I am, that's who I am, that's who I am. I realized that I really enjoy teaching remotely. So back in May, I decided to try streaming on Twitch. And here we are. This is my passion, and now I get to share it with you. And what could be cooler than that? I believe that scientists ought to be public servants. Ultimately, it's our job not just to make scientific discoveries, but to teach the public about them. That's exactly what I want to do here. Now, because of COVID-19, this will be my first summer in almost 10 years with no fieldwork. I'm trying to look on the bright side, though. It's not all bad. At least I have more time for outreach. And I've got plenty of cool stuff to work on. And if you could throw some support my way by subscribing, I'd be incredibly grateful. So anyway, if you are new here, you should be pretty well clued in by now. And I'm glad you're here. I hope you're having a good time. Anyway, let's see what present-day Danny has cooked up for us. All right, present-day Danny, back to you. Well, thank you very much, previously recorded Danny. And of course, thank you even more to J. Marianne for that raid. I really appreciate it. It's wonderful to have you here. Today, of course, we're talking about dinosaur reproduction and courtship and all that good stuff, and what we can possibly learn about that from the fossil record. It's Valendinos. So let's get back into it, shall we?
The crowning touch in sexual headgear belongs to the breed of dinosaurs known as the ceratopsians, especially the most famous of them, Triceratops, named for its 3 horns. When paleontologists found Triceratops in the same layers of Earth as T. rex, they assumed the frills and horns were defensive structures.
Which you can see why they would come to that conclusion early on. By the way, this documentary is from 1994, so it's a couple years old. And a lot has changed in our thinking about dinosaurs since that time. But I think not enough has changed for a lot of this stuff. Some of these ideas still get taken seriously when they really shouldn't be. But, yeah, anyway. The idea that ceratopsian horns and frills were used for sexual display, primarily, doesn't make a lot of sense. One of the common themes here, one of the things we're going to hear again and again and again for the next, 20 minutes as we continue this. In order for a feature to have evolved for sexual display, it kind of needs to be different between the different sexes. And they don't seem to be for dinosaurs. We don't have, as far as we know, differences between male and female Triceratops in terms of their cranial morphology. They seem to be identical. Like, there doesn't seem to be a good way to tell the difference between a male and a female Triceratops. We don't know how. It's not like we've got one kind that looks this way and then the other 50% look that way. It's not like that at all. So the idea that this was used for sexual display just doesn't make any sense, I don't think.
But as other ceratopsians came to light, their elaborate headgear was not so easily explained. They were too widely varied to be used simply for defense, too fragile for anything, attack, defense, or sexual headbutting.
Sure. Yeah.
To learn why the dinosaurs had such elaborate headgear, paleontologists looked to modern animals. Antelopes developed many sizes and shapes of horns, but not for attack or defense. The horns signal their sexual maturity to mates. And
as a result, they tend to be different between males and females. The males have got much larger, more elaborate headgear than do the females in bovids and in ungulates like this.
Intimidate would-be rivals.
And Annie Phrasis says, do we know if dinosaurs had highly developed eyes? We do know that they did. Yeah. Maybe they just had different surface colors. And that, ding, ding, ding. Yes. Birds are a good example of this. Birds today are living dinosaurs. Birds, like we talked about, are the last surviving dinosaurs. They evolved from a dinosaur ancestor. They are dinosaurs. So, birds today, they often have striking sexual dimorphism, but it tends to be in two different things. In terms of their size, so sometimes the males and the females are different sizes. In a lot of birds, the females are larger than the males, and some birds, the males are larger than the females, so they can vary in size between the sexes. But coloration is the big thing. Males tend to be more brightly colored than females. There's a few exceptions to this, but that's the general rule, is that males tend to be more showy, more brightly colored than females. Birds have full color vision, for the most part. There's a few birds like owls that don't. But birds in general have much better color vision than people do. Birds can actually perceive colors that we can't even imagine, because they can see part way into the ultraviolet spectrum, where our eyeballs can't do that. We don't have tetrachromatic vision. We have trichromatic vision, so we can see like 3 major groups of colors. Birds can see 4. Dinosaurs would have been able to do the same thing. Since birds evolved from dinosaurs, much of what makes birds cool and interesting and different from other kinds of animals is like inherited traits from their dinosaur ancestors. I talk about that in this infographic that I put together right here. We talk about this every November. Theropods Giving, we call it. Birds are a kind of theropod dinosaur. Here's the skeleton of a turkey. Here's the skeleton of a velociraptor. almost everything that makes birds different from other animals today, from their S-shaped neck, to their unique ankle joint, to the morphology of their wrists, to the presence of a wishbone in the chest, even their feathers. These are all dinosaur traits that they inherited. Dinosaurs evolved all of those traits first. Birds simply inherited them. Same goes for their eyeballs. So the color vision that birds have is something that their dinosaur ancestors would have had too. That's where birds got it from. And so there's a decent chance that that the primary way to tell a male from a female dinosaur, the way to tell them apart visually, would be by their coloration. Unfortunately, that sort of thing doesn't generally fossilize, not often at least. So it's difficult to test, but we've got every reason to presume, I guess, that male and female dinosaurs would have been, they would have had different colorations, just like birds. So anyway, let's continue.
Ceratopsian dinosaurs like Pachyrhinoceros developed different headgear at different stages. Paleontologist Darren Tankey of the Royal Tyrrell Museum of Alberta, Canada, studies Pachyrhinoceros fossils for clues to the animal's age and sex.
What we have here are 3 casts of reconstructed skulls of Pachyrhinoceros.
Darren Tankey's so young there. This is nuts. Now that we've got more skulls of Pachyrhinoceros, I don't think this holds true anymore, and I don't think Darren Tankey would say this nowadays, but yeah.
This one, which we believe to be a female, this a male, and this a juvenile. The frill on the juveniles and young adults have this simple pie crust edge type effect.
Yep.
And in the adults, we have some very large horns developing on the back of the frill. These do not develop until the animal reaches full adult size and presumed sexual maturity.
Yep.
And previously it was believed these horns were for protection only. I think it's now fairly clear that this is Mother Nature's way of saying that, A, I'm a male or female Pachyrhinoceros.
So it turns out that there's so many in-betweens, it's not like these guys can be neatly sorted into these ones are male and these ones are female. It's much more of, it's a spectrum. So you don't get like a bimodal distribution here at all. This isn't a male-female thing. And I bet you if Darren Tankey were talking to us right now, he'd say, oh yeah, that's an old idea. We don't think that anymore.
And B, I am of breeding age.
The sex of the Pachyrhinoceros is anyone's guess until it reaches adulthood and develops headgear. Paleontologists believe the adult female's horns are less ornate than the longer and more pronounced horns of the full-grown male.
So part of this is probably ontogeny, where like the more pronounced the horns are, the older the animal is. And part of it just seems to be individual variation. Again, we were talking about this yesterday. Yeah, so this is a talk from, what, last year, I think?
So this is one of the really interesting things that Pipestone Creek is really bringing to light, is that these features that are often used to define horned dinosaur species may not be a good feature to define species based on, because they are hugely variable even within the same community.
Yep.
So that's one of the interesting things that's coming out of Pipestone Creek. Again, this is one of the research questions that my team and I are actively working on.
So, yeah. I don't think anybody seriously thinks that this is a male-female thing anymore. Really cool talk, by the way. I'll give you a link to it right there. Yeah. Good stuff. Anywho.
Those dinosaurs without elaborate headgear, like the giant brontosaurs, may have advertised their intentions with color, turning themselves into walking billboards for sex. Barker thinks the largest dinosaurs, unlike large land animals today, were quite colorful.
I agree. Yeah.
The reason big animals today are gray is because they are color blind. They don't see in color.
Yep. Yep.
They're big mammals. Big mammals are colorblind, but birds see color. Well, alligators and crocodiles see color too. So do lizards. You see a panoply of bright colors in fish and frogs. Did dinosaurs see color? Their eyes were built like birds, mostly, a little bit like crocs, and they must have seen a full range of reds and yellows and blues. So, of course, a bull brontosaurus would have some iridescent blue around its eye, maybe a ring of yellow and red around its throat to advertise itself.
The most elaborate
And yes, indeed, Casey Snort, most mammals are mostly colorblind. You know, you've probably heard that dogs are colorblind. That's not entirely true. They can see some shades of, like, I think yellow and green, but they don't have, like, full color vision in the way that primates like we do. And we don't even have full color vision, like, not like birds or other reptiles or fishes or amphibians. But yeah, most big mammals, most mammals in general are mostly colorblind. Yeah.
Assortment of crests and colors.
And Ebola Heavy Rocks is the consequences of our nocturnal ancestors. Bingo. Yes, yes indeed. Because our mammal ancestors were mostly running around at night during the age of the dinosaurs. You got to remember that mammals have been around for about 200 million years, 220 million years, something like that, depending on where you consider the first mammal. For like 140, 150 million years of that span, that was during the age of dinosaurs, when mammals were mostly very small, mostly living in the underbrush, mostly coming out at night or living underground in burrows or in, tree hollows during the day, whatever. And during that time, they mostly lost the ability to see in color. They adapted toward night vision. They got rid of most of the cones in their eyes, the color-sensitive cells, in favor of rods, light-sensitive cells. And that's why, to this day, most of the mammals are various shades of brown, or gray, or grayish-brown, or brownish-gray. Most mammals are not very brightly colored because they can't perceive color. At least not in the way that reptiles and amphibians and fishes can. That's why most mammals are pretty dull colored. It's because they don't have color vision. But yeah. And most mammals still operate at dawn or dusk. It's a thing. I mean, that is also largely true, Gojira. There's also a surprising number of mammals that live in burrows, at least during part of their lives. Often they raise their young in burrows. Probably a holdover. An ancestral trait from when most mammals were living kind of under the heel of the dinosaurs, So yeah. Anyhow, hope that makes sense. Let's continue.
Belong to the duck-billed dinosaurs.
Of course, a bull brontosaurus would have some iridescent blue around its eye, maybe a ring of yellow and red around its throat to advertise itself.
The most elaborate assortment of crests and colors belong to the duck-billed dinosaurs, like Critosaurus, whose classic profile earned it the name noble lizard. Its cousin, Saurolophus, used a 2-foot head spike to get itself noticed. The fan-shaped hollow crest of the Lambeosaurus surely made it stand out in a crowd. But the most prominent of the duck-billed dinosaur crests was that of the Parasaurolophus.
One of the most prominent, yeah.
Of all the extravagant sexual displays, this was the most baffling. Weighing up to 4 tons, the mighty vegetarian was endowed with a 6-foot hollow crest.
Elvis, Darius Majewski, there you go, yeah.
Year mystified David Weishempel, a paleontologist from Johns Hopkins University.
The crest itself is very, very fragile. It's built out of very thin bone. Probably couldn't withstand a lot of this head-to-head stuff like you see in bighorn sheep.
Yep.
Because many Parasaurolophus fossils had been found in marine sediment, many paleontologists suggested the horn was used as a snorkel when the giant beast went swimming.
I don't think any of them have been found in marine strata. What?
But a Swedish paleontologist named Carl Wieman solved the mystery.
Yeah, unlike a snorkel, it doesn't have a hole in the end. So, you know, that hypothesis you can discard.
Carl Wieman in Uppsala got himself a duck-billed dinosaur with a hollow crest. He looked at it and said, "It looks like a trombone." It was a trombone. It was for making loud courtship noises.
David Weishempel wondered what the 70-million-year-old love song of the Parasaurolophus sounded like. He knew that when the animal exhaled, the air would shoot up the windpipe to the back of the crest into the throat and out the snout. Weishempel built himself a horn as long as the crest and taught himself to play it.
Well, this contraption that I've got in my hands here is, in fact, a model of the crest of Parasaurolophus. It's the right size and the right shape for Parasaurolophus. It's built out of PVC tubing. And the reason I built it was to get a better sense as to the kinds of sound that Parasaurolophus would have made. So why don't I play it for you?
This unique love song no doubt made the Parasaurolophus the diva of the dinosaurs. Using the trombones in their heads, they serenaded mates and repelled rivals. After all the singing, stomping, and headbutting was over, the dinosaurs finally got down to some real romance. Just how they did it, the fossils don't say, but some scientists have reached their own conclusions. The late Beverly Halstead, a British professor of geology and zoology, was noted for his candid theories of dinosaur sex.
Is to discuss one or two aspects.
He speculated that the male mounted the female from the rear, twisting.
So we can be mature about this, right?
To align the sex organs. The male would have to keep one foot on the ground to avoid crushing the female during mating. Halstead not only published his theories, he famously demonstrated them in his lectures.
That we're interested in is about there. That is the critical part. So if we take up the same position again, down of it like this, imagine now that I have a tail coming here, and my hand is doing, I can actually get under, twist my tail, she can twist her tail, and we can get the two cloaca into direct, correct position.
Pretty sure these two are married. Yeah. Anyway.
This precarious three-point stance seems to work for most dinosaurs. But consider...
And it makes sense given a certain kind of pathology that we actually see in dinosaur fossils too. Somebody in chat mentioned this from last week, and I'm glad they did. Here. We talked about this when I was in North Dakota. Visiting the Badlands Dinosaur Museum, curated by Denver Fowler here. My old crew chief. And let's talk about Warwick's duck. Where is that? Here we go.
And my dad came across some neural spines, some vertebrae pieces sticking out of a hill. And we went over there, and it's like, well, you could see it was going in, so that looked promising. So we dug in. After a couple of days, this is what we found. And it was a little bit disappointing because it was just a section of tail and part of a leg. There were a couple of neck bones, but there wasn't much else. But when we started cleaning up the vertebrae more, we noticed that they were injured. badly injured, and not just one or two injuries like you often see, but this had injuries across like 20 vertebrae.
Jeez. And
this is in fact one of the best examples of this kind of pathology, this kind of injury that you can see on any hadrosaur in the world. And Filippo, who's watching this, he's writing papers about this specimen and a number of other specimens as well. He's an expert on
pathologies in ornithischians, yeah.
Yeah, pathologies in ornithischians in general. So, we presented on this in 2019 at a conference we were holding here. And basically what's really cool is that each one of these broken spines shows the same injury.
Yeah.
It was
wild.
From above.
So it... Oop. No, shoot.
Left side. And then the spine. Yeah. It was hit from above, and the spine was broken and shoved down to the left side. And then it healed, if you can call this healing, and some of those broken spines have kind of fused onto the left side. Other places they're completely missing. Some places they're just buckled rather than broken. And a little bit later I can show you another specimen that we have of a Brachylophosaurus, which is from 8 million years before these guys, which shows exactly the same injury. And that's what's really interesting. We see this kind of injury in duck-billed dinosaurs. So not just Edmontosaurus, this is an Edmontosaurus, but we see it in Brachylophosaurus, we see it in Iguanodon, we see it mostly in the hadrosaur, more derived forms. These broken spines, usually from the middle or late in the back, and then down the tail. It's been suggested that maybe this is the result of like tyrannosaur attacks, that kind of thing. But the problem with that is that there's not really any evidence for that. The suggestion was the specimen in the Denver Museum has like a little notch in the tail, and it was just the right size and shape for a tyrannosaur bite. But anything that's a rounded gap will be the right size and shape. And this is not. This is all the way down the tail. And in fact, there's many specimens that look just like this. And you can tell that these are impacts from above as well. So we think these are mating injuries.
That's what somebody in the chat suggested, yeah.
Yep. That's what we think these are.
Yeah, yeah. It would make a lot of sense. So how would you
test that hypothesis?
Well,
figure out if this was female.
That's one of the challenges. Like right now, telling male and female dinosaurs apart is almost impossible.
Yeah.
If you're really lucky, you could look inside the leg bones and you might find medullary, a special kind of bone tissue that the females lay down when they're doing calcium storage type things for eggshell and things like that. So if you were lucky, you'd find that. But if you don't find it, that's not an indication that it's male.
Right.
It just means it's not a laying female.
Yeah, yeah.
So it's you could look at percentages and things like that. There's a few different ways to investigate that, and that's basically what Filippo's working on.
Oh, cool.
His research.
He said that he just got back on that recently too. He wants you to know.
Oh, good.
So
good. Yeah. It's really cool. I think absolutely, I agree. I mean, people think it's kind of wild, but you know what? It makes more sense than anything else.
Yeah.
Unless hadrosaurs had a habit of like flipping over and smacking on their back, which is
they really like doing front flips, but they weren't very good at it.
Well, they just were really clumsy and kept standing next to trees that fell over.
Yeah.
Everything else would just be accidents, whereas this is more, there's something about this body plan that makes them susceptible to a particular kind of injury.
And this is not an injury that happened while the animal was really small. It's not like an adult stepped on it when it was only a meter tall or anything.
Well, when did this injury happen is a question. And you can look at the amount of healing, again, if you can call it healing, but these bones aren't just broken, they fused up, but there's still some inflammation around some of the broken areas. So I'm not a bone pathology expert, so I don't know how long it takes for that kind of healing to take place, but it's obviously not the space of just a few days. This is at least weeks and weeks, I'd have thought, if not months and possibly many years. I don't know. Filippo surveyed this kind of injury in many individuals, and I don't know if there are any of them that show, I don't know, finished bones. So that's his research. I don't know. But
Casey Snowart says, seems like such a painful way to procreate if it means you have to break so many bones to get the next generation going. it might not be that all of these injuries happened at the same time. This could be cumulative over decades worth of, you know, like repetitive procreation. I don't know. Like, it's going to be really interesting to see what Filippo comes up with here. Yeah. And it might be an experience that isn't the norm. I mean, it could be Claire. I don't know. What does seem clear is that since you've got so many healed injuries here, this is not, you know, if they hadn't been healed, if they had killed this animal, it'd be like, okay, shoot, well, but they were healed. Like, clearly the animal lived for a long time after having been injured. And so maybe that's a small price to pay to ensure that your genes are passed on. I don't know. And I don't know how common injuries like this are in animals today. There are not very many mammals that have got long, bony, muscular tails like this. So it's... And we don't have that in birds either. So it's difficult to make an analogy like that, to be able to look for a similar... To look for an analog in modern animals. Because who else has a giant muscular tail like that? Crocodilians do, but they generally mate like belly to belly in the water. So they're not going to be doing stuff like this. And also they don't have those tall neural spines in the same way that hadrosaurs would, you know? So it's, yeah, it's tough. Nothing is shaped like dinosaurs anymore. Exactly, Claire Bird, yeah. Yeah, they don't make big land animals like they used to. You know? All this mammal nonsense nowadays. They don't make them like they used to. And Casey says, did Denver do histo on this fossil? Yes. As far as I know, yes. And Filippo Bertozzo, who goes by Dyson Dinosaur, he's here on Twitch. He's working on this specimen. That's what Denver was talking about earlier. Yeah.
Kind of injury in many individuals, and yeah. I don't know. Filippo surveyed this kind of injury in many individuals, and I don't know if there are any of them that show, I don't know, finished bones. So yeah. That's his research. I don't know, but that's the sort of thing that we can look at.
Very cool. Yeah. Yeah. So here's a link to that VOD if you'd like to take a look. This was last Monday, just a little over a week ago. I was there in North Dakota. It's one of my favorite streams I've done in a long time. So anyway, we got to finish this thing out so I can finish the stream. So let's continue.
The Stegosaurus. It literally points out the problem with Halstead's theory. How the male Stegosaurus felt the next morning, no one can say. By all accounts, the impressive size of the dinosaurs was not matched by the size of their sex organs. Like modern
we don't really know.
Male dinosaurs had no true penis.
We don't know if that's true either. I mean, some birds today do have that, and crocodilians do too. So I don't think we have any reason to think that dinosaurs wouldn't. So I think this part is incorrect.
The sex organ, called the cloaca, is set back beneath the tail, as it is in birds and lizards. Some male dinosaurs had a specialized bone at the base of the tail to maneuver the cloaca into position. The chevron bone of the mighty male T-Rex, for example, is a mere 8 to 10 inches long, and Halstead claimed that the sex organ of a 4-story, 70-foot-long brontosaur would have been, at best, a mere 1.5 feet in length.
We don't really know that. I mean, one of the ideas for how sauropods would have made it almost is like they back up to each other and put their tails up, and maybe the male has like a prehensile organ, kind of like, you know, whales have. We don't know because this stuff doesn't fossilize, you know? We really legitimately don't know.
Darren Tanky believes that he had found proof that dinosaur sex was not only awkward.
And there you go, Casey, yeah. Yeah.
Literally hundreds of broken and re-healed spines on the tails of the duck-billed dinosaurs.
Here we go. Yeah.
You can see large bony growths, and when you look at it end on, you can see that the neural spine, this process right here, has been bent and twisted. And from looking at it, I can see at least 2 or 3 different fracture sites that have mended, they've been re-healed.
Some scientists have proposed an obvious solution. Duckbills were social animals, getting in each other's way and stepping on tails, except that the breaks were more common at the base of the tail, not the tip.
Now, when you look at these, you can actually try to and begin to establish how they may have been formed. And it looks like a great weight has pressed down on them from above. It's either that or the animal's
exactly what we were seeing in the museum.
On its back and collapsing under its own weight. But I cannot see any reason why an animal would be doing that.
Paleontologist Lou Jacobs has conducted extensive digs in Texas. He considers Tanke's theory improbable.
I don't think that makes too much sense because, you know, the point of...
we saw Lou Jacobs earlier in today's stream. Remember?
My name is Louis Jacobs, and I'm one of 2,300 vertebrate paleontologists from 54 countries that belong to the Society of Vertebrate Paleontology. Because we study fossils, especially dinosaurs, we capture the imagination of children, and that makes vertebrate paleontology a gateway for all science.
So, yeah, Lou Jacobs. This is him decades earlier.
Improbable.
I don't think that makes too much sense because, you know, the point of sexual reproduction is to have offspring. And there needs to be some sort of element of pleasure in it, and I don't think breaking your tail is a particularly pleasurable thing or adaptive, and I doubt that it happened too much, if at all.
I don't know. That doesn't strike me as a particularly convincing argument.
Even if sex for the dinosaurs wasn't much fun, it clearly worked. So what were the dinosaurs like as parents? Until recently, paleontologists assumed they were like many modern reptiles. They laid their eggs and moved on. But now tiny bones of baby dinosaurs are emerging and casting their parents in a different light. As we learn more about the sexual habits of dinosaurs, our picture of them is changing.
Here's Jack.
Jack Horner of the Museum of the Rockies in Bozeman, Montana, has done a lot to bring that about. Horner is a fossil hunter's Indiana Jones. He has found more dinosaur bones than anyone, but he has never found the fossils of an infant dinosaur. One day, quite by chance, Horner stopped at a rock shop near Shodo in northern Montana.
In Bynum, Montana.
Nearby Badlands, the owner had found tiny bones she could not identify. She asked Horner to take a look. Horner realized he had stumbled onto the very thing he had been looking for, the bones of dinosaur young. With a team of graduate students, Horner immediately began excavating the site where the bones had been discovered. What they found was not just baby fossils, but an entire nesting ground and scores of fossilized dinosaur eggs
I think those are the same Troodon eggs we saw earlier in the broadcast, too, in the other video.
Stood together.
Yeah.
The site would become known as Egg Mountain, and it was here that Horner would change forever the image of dinosaurs as monsters. These dinosaurs had cared for their young.
Yep. Good mother lizard, Maiasaura.
Finding dinosaur eggs and dinosaur babies changed the way people looked at dinosaurs, because people had always looked at dinosaurs, well, they'd looked at dinosaurs two ways. They'd looked at them as large adults, and they'd looked at them as skeletons. And I mean, our museums portray dinosaurs just as skeletons, sort of dead things stood up. And the baby dinosaurs, the eggs, finally brought life to them.
Now we have a sense of the complete dinosaur from hatchling to mature sexually active adult to old grandmother.
The love lives of the dinosaurs have given us our first complete picture of these fantastic creatures. They flirted and they fought. They tooted their horns and they flaunted their sexuality with colorful abandon. From the buried secrets of dinosaur sex has come a new awareness that the swamps and forests where they lived were not only places of terror, they were places of primordial passion.
There you go. Paleo World. Salute for the anthem. I hope you all enjoyed. Hope you learned something. I certainly learned some things today too. It's been a pleasure talking about all this with you, and I hope if you've got Valentine's Day plans, you're excited for them, and I hope they go well. If you don't, more power to you. We're not going to get to Thursday Birds Day today. We'll have to have a super extravagant Thursday Birds Day next week. 3 Thursday Birds Days worth of birds next Thursday. It's going to be good. But it's time for me to wrap things up here. So let's see who we can raid into to continue our science for the evening. And, yeah, thank you, everybody, for everything. Here. Let's start up our credits here. Thank you to everybody who's about to be named in our credits. And who is on right now? Let's see here. Let's go ahead and raid into MCK Gaston, perhaps. Yeah, good stuff. Let's see. Who is a botanist, plant scientist. He's playing some Minecraft right now, so if that sounds like fun to you, well, this is going to be great. Thank you, everybody, for an excellent stream. Thank you for your enthusiasm. Thank you for your questions. Thank you for your financial support. Thank you for the subscriptions and the resubs and the primes and the gifts and the cheers. Thank you to new followers. Thank you to moderators for working hard today. I know today was, I don't know, talking about dinosaur reproduction. You were, really had to be on guard today, mods, and I thank you very much for that. You did a great job. Appreciate you. I'm going to do some museum stuff tomorrow. I'm going to see if I can finish that Tyrannosaurus skull, assembling that, and do some more paleontologizing on Monday. Hope to see you then, everybody. But for right now, let's go check in with MCK Gaston and all the wonderful weekend. Happy Valendinos. I'll see you around. Take care.